plenary speakers, moderators, presenters, delegates, ladies and gentlemen. Welcome back to the second day of the 8th International Conference on Geoscience and Earth Resource Engineering, ICGERE 2026. And it is my pleasure to serve as your Master of Ceremonies for today's event. Before we start, please allow me to share the short safety induction.
Safety Induction, keamanan, kesehatan, keselamatan kerja dan lingkungan di ITB. ITB berkomitmen untuk mencapai kinerja terbaik di bidang keamanan, kesehatan, keselamatan kerja dan lingkungan yang mencakup aset sumber daya manusia, bangunan, peralatan, dan kekayaan intelektual. Oleh karena itu, ITB mengharapkan kesadaran setiap individu yang berada di area ITB untuk turut berperan dalam mewujudkan kondisi keamanan, kesehatan, keselamatan kerja dan lingkungan yang kondusif dengan memenuhi pedoman keamanan dan K3 yang berlaku di lingkungan kampus ITB sebagai berikut. Setiap individu diminta untuk meluangkan waktu memahami lokasi kegiatan dengan melihat peta lokasi yang memuat jalur evakuasi, lokasi pintu darurat, tempat berkumpul darurat, tanda kedaruratan, lokasi pemadam api ringan, dan kotak P3K. Terdapat pintu darurat dan assembly point atau tempat berkumpul yang aman di setiap gedung. Jika diperlukan evakuasi, panitia pendamping atau satpam akan memandu. Setiap individu wajib turut menjaga kebersihan gedung dan area dalam ITB, serta membuang sampah pada tempat sampah yang telah disediakan. Setiap individu diimbau untuk tidak meninggalkan barang tanpa pengawasan karena alasan keamanan. Tidak diperkenankan merokok di dalam gedung dan di kawasan kampus ITB, kecuali di area merokok. Harap dipahami bahwa keberlangsungan kegiatan dan acara adalah di luar dari pelatihan keadaan darurat. Jika alarm tanda bahaya terdengar, maka nyata terjadi kondisi darurat. Jika terjadi kondisi darurat atau menemui benda atau orang mencurigakan, kecelakaan, atau kondisi tidak aman lainnya, silakan menghubungi petugas keamanan terdekat atau nomor darurat ITB di 022 250 02 04 untuk area ITB Ganesha dan 022 860 10 020 untuk area ITB Jatinangor. Demikian pedoman ini kami sampaikan. Terima kasih atas kerjasama dan perhatian Anda. Utamakan keamanan, kesehatan, keselamatan kerja, dan lingkungan.
Okay, thank you so much for ladies and gentlemen for the attention to the safety induction. Before we begin, I would like to say thank you to Dr. Filda C. Yusgiantoro ST MBM MBA, Chairperson of the Purnomo Yusgiantoro Center, editorial team of the Indonesian Journey Energy, and then Mr. Muhammad Haryadi Setiawan, Director of PT Lapi Institut Teknologi Bandung, Prof. Insinyur R. Muslinang Mustopo, MSEM, PhD, Chairman of the LAPI Foundation Institute Teknologi Bandung, Prof. Dr. Engineer Syafrizal STMT, Dean of the Faculty of Mining and Petroleum Engineering, Prof. Dr. Science Insinyur Andri Dia Nugraha SSI, MSI, Vice Dean for Academic Affairs of Faculty of Mining and Petroleum Engineering, Insinyur Taufik Hidayat, ST, MPhil, PhD, IPM, Vice Dean for Resources and Faculty of Mining and Petroleum Engineering, Dr. Engineer IR Fadila Ahmadi Roshid, STMT, Mineral and Coal Economy Mining Engineering, ITB, Dimas Taha Maulana, STMT, Geothermal and Petroleum Drilling and Production, Geothermal Engineering, ITB. And also, lastly, for the invited guests, heads of undergraduates, master's, doctoral study programs, and heads of research group. Thank you for coming to today's event. Today we have a very rich program with floor plenary sessions and two technical presentation blocks featuring speakers from Institut Teknologi Bandung, from industry, and from the University of Cambridge. So without any further delay, let us begin the second day of ICGERE 2026. We begin today's scientific program with plenary session 4 of mining engineering. Our plenary speaker is Dr. Engineer Insinyur Fadila Ahmadi Roshid from Mineral and Coal Economy Mining Engineering Institut Teknologi Bandung, and there will be Dr. Engineer Tommy Alvin Rifai as the moderator. To Dr. Engineer Insinyur Fadila Ahmadi Roshid and Tommy Alvin Rifai, please come to the stage and the session is yours.
Good morning, ladies and gentlemen. Thank you for coming to this plenary session. Today we have one of our plenary speaker, Dr. He is an assistant professor in mineral economics. So on daily basis he is teaching at mining engineering department. Dr. Fadila graduated from Akita University, I think in 2017. He got his PhD in mineral economics after he received his master and bachelor degree in Bandung. So currently, he's working as lecturer. And from 2020, I think until last year, Dr. Fadila was the head of mining engineering program in ITB. And also in the same time, 2023 until 2025, he was the member of the audit committee of PT Bukit Asam. So without further ado, please welcome to deliver his talk. So we have 30 minutes.
Cek, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and good day, everyone. I think usually in the second day of a conference, the participant was less than the first day. So the chairs, the number of the participant less the number of the chair. So if you don't mind, please move forward. So we can have intimate conference. Thank you very much, Dr. Tommy. Today I think I will deliver not complicated materials. I will talk about the policy in mining industry and also have an impact to the smelter or processing industry. Even though this material is not complicated, but it will affect our future, especially the one who engage with the mining industry and also the processing industry. For mining and metallurgists, this regulation regarding the new regulation on benchmark price of coal and minerals will affected our industry. Okay, these materials prepared by myself and also my colleagues, Dr. Firly, and also two of our students in mining engineering department. Next. Okay, this is the outline of my presentation. We will start with the introduction, and then I will come to the policy highlight. Give the example of a case study in mining and processing industry. We will have a discussion and closing remarks. Okay, before we start with the presentation, I think I will remind us regarding the ownership concept of Indonesian minerals resources. This is a little bit different with the other countries since there are many ownership type. Yeah, we call it mining right. Yeah, and then authority right, mining right. Sorry, mineral right, authority right, mining right, and also economic right. Who each this ownership right will be held by different party, but all of this right suitable with the highest law in Indonesia, Article 33, Paragraph 3 of the 1945 Constitutional of Republic Indonesia, which the land, waters, natural resources contained therein shall be controlled by state and utilized by the greatest for the greatest prosperity of the peoples. This the concept of the ownership. That's why the ownership will be divided into 4 types. Mineral rights owned by Indonesian people. All of us is the owner of the minerals and coal in Indonesia. But the authority right will be represented by the state. And then the state will deliver the mining right, yeah, the one who will issue the mining right to the central government, yeah, and also the regional government. For the central government, will responsible for coal commodity and also minerals commodity. But for the and then for the provincial government or regional government will have responsible for the stone and industrial minerals. After mining right is given, yeah, to the holder of the mining right will take control of business right. So business right will be represented by business actor. So we will have to keep in our mind regarding this ownership concept on Indonesia mineral resources. Why the ownership concept was designed? Yeah? This is to ensure that our nation will get high benefit from the utilization of coal and minerals. Unfortunately, yeah. From this slide, yeah, I can give you information that the contribution of coal in minerals relatively high, because contributing approximately 22.7% to the GDP of Indonesia. And then if we take a look on the export, yeah, 62.7% of export dominated by the coals and mineral products. So from this side, I think we can conclude that minerals and coal give the higher impacts on Indonesian's economy. In the next point, natural resources, PNBP, or we can call it royalty, is dominated by mineral and coal from mining sector, particularly coal, which accounted for 71.56% of mineral and coal royalty. So from the government income, about 70-something% dominated by coal. In the contrast, the contribution from the forestry and fisheries sector that relatively low. From the regulatory fragmentation, benchmark price that do not adequately reflect actual market value and suboptimal tariff structure create risks and also underpricing, transfer pricing, misconfishing, and also fiscal leakage. Why I raised the issue regarding the transfer pricing of mineral product? We all know that most of Indonesian smelter owned by Chinese. So the price of the nickel metal will be regulated or controlled by China. Somehow, yeah, nickel from Indonesia will be bought with the relatively low price compared to, let's say, London Metal Exchange. That's big, that become a problem if we discuss regarding the government income. So why the government needs to regulate the price and price of minerals and coal? There are many reasons that government needs to control the price. First is protecting state revenue. Benchmark price will provide an essential reference for calculating production levies or royalty and also other fiscal obligation. So if we know that government have the priority program like MBG, yeah, or COPDES, it could be that the resource of fund for that program comes from minerals and coal revenue. So if government needs to collect higher income, one of the sector that could be or possibly provide more revenue is coal and mineral sector. The second, the importance of regulating the price and price of mineral and coal is preventing unfair pricing practice. Yeah. Also maintaining market stability and business certainty. So if government regulate the price of raw materials, mining providing raw materials, these raw materials will be used by smelting industries. So if the price of raw materials stable, the downstreaming industries will also get the benefit. So in my opinion, the visibility of the downstreaming industries will be depend on mining industry. And then the next reason, promoting fair and transparent trade. Yeah, call of the benchmark price will provide index price for the negotiation between the producer or mining industry to the processing industry. Next, yeah, the important is balancing miners and downstream industry interests. Then supporting downstream development and domestic supply. Let's say if government provide index price, which this index is relatively higher than market price, world market price, so no intention for the mining industry not to supply to the processing industry. And then the last reason, strengthening oversight and compliance. Okay, I will show you the regulatory timeline for the coal and mineral benchmark price. It is start from 2017 to 2020, which in this period, yeah, benchmark pricing framework for minerals and coal sales was structured through regulation and updated through regulation number 11 2020. This regulation effectively implemented start from May 14, 2020. Yeah. And then in March 1st, 2025, yeah, I think in this period, the president is Mr. Prabowo Subianto. In this period, Indonesia began using government benchmark coal price as floor price for transaction and shifted publication to the 1st and 15th of each month. Previously, the index price only issued one times in a month. So start from 2025, yeah, the index price will be issued two times. The beginning of month, in the middle of each month. And then August 8, 2025 degree. In this degree, all sales below benchmark while keeping taxes and royalties linked to the HPM and HBB or benchmark price. In this context, I can say that government have index price, yeah, reference price, but if the mining industry sell below the reference price, the basis for the taxes or royalties will use the higher price. So the index price will be used as the basis for royalty. But if the condition is different, when the transaction price higher than reference price, so that higher price will be basis for the estimation or calculation of royalty. And then the latest regulatory timeline is April 15, 2026, which revised previous decree that the method for determining benchmark price for metal and mineral will little bit different, but will provide different impact to the mining industry and processing industry. Okay, this is the policy highlight for coal and mineral pricing. The basis for regulating mineral and price may be derived from our highest constitution, UUD 1945, yeah. And then the state authority to determine mineral price is further affirmed through the law number 2, 2025. Yeah, the second one, which provide that in the national interest, the central government is authorized to determine the production volume, sales, price of metals, and also coal. So in this context, yeah, government not only regulate the price, but also the quota of production in our nation. And then following the law number 2, 2025, yeah, the principal provision governing benchmark price are stipulated in government regulation number 39 of 2025 concerning the implementation of mineral and coal mining business activity. And then from the technical perspective, the procedure for determining benchmark price for the sale of metal mining and coal are regulated under Minister of Energy and Mineral Resources number 11, 2020. Okay, and then the lowest, the lower regulation was which key regulating governing mineral and coal selling price is Minister of Energy and Mineral Resources decree in year 2025 concerning the guidelines for determining benchmark price for sale of metal, minerals, and coal. And the last decree regarding the benchmark price formula is set out in Minister of Energy and Mineral Resources decree number 144.k.mb.01 MAM.b 2026. In this context, yeah, especially for benchmark price formula in coal ore was revised to incorporate not only nickel content, but also associated minerals, uh, which available in the nickel ore, such as iron, cobalt, and also chromium. So if we estimate using this formula or the latest formula, somehow the price of nickel ore is relatively higher. Okay, this is the formula of previous regulation and the latest regulation. We can see that above is the formula for the previous regulation. Price of nickel ore only consider nickel content. After the new regulation, if we estimate the nickel ore price, we have to incorporate not only nickel, but also iron, cobalt, and chromium. Unfortunately, in both regulation, yeah, will affect it not only for mining industry, but also smelting industry, because the revenue, higher revenue for mining industry uh, will become a higher cost for smelting industry. So if you see the new regulation, yeah, the price of nickel ore is higher than previous price, yeah, mining industry will get more benefit, more revenue. But it is a curse for smelting industry, because the cost for smelting industry will getting higher and higher. So it will also affect it royalties and also income tax get by the government. So it is necessary to ensure a fair and balanced framework so that all stakeholders can obtain equal benefit. So yeah, this is the case of standalone mining industry and smelting industry. But I think if we take a look on integrated mining industry and smelting industry, the situation is different because if the nickel mine and smelter owned by the same company, yeah, output of nickel mine, yeah, which is cost of mining, depreciation, and amortization will go as cost for the smelter. So the impact is not so high compared to the standalone mining and smelting industry. Okay, I will show you our hypothetical financial model, because to prove this situation, we built the financial model with this kind of assumption. Start from nickel ore characteristic, which contain not only nickel, consider not only nickel, but also cobalt, iron, chromium, and so we have to consider moisture content. Yeah. We built the model using the annual production 4 million wet metric ton per year. Yeah, the total cost of saprolite around for mining. Yeah, actually $21 per wet metric ton, royalty rate 14%, depreciation using unit basis. $3 per wet metric ton, and also capital expenditure. If we use this nickel ore characteristic, and we estimate the nickel ore price, yeah, we can see the below price. Nickel ore price estimate using the 2025 regulation is 47.6 US dollar per wet metric ton, but for using the new regulation, the price getting higher, 65.66 US dollar per wet metric ton. To prove this situation, I also built the financial model for smelting industry. The right side below is are the assumption for the smelting industry using 4 million wet metric ton input and also 1.6% nickel contain. The nickel production, nickel metal production, about 37,000 million ton, 37,000 ton per year. So, okay, this is the financial model. The above table for the previous regulation and the below table for the new regulation. I will go through this for the nickel pig iron smelter. If the smelter using the ore price with the benchmark in regulation 2025 and 2026. This is the result, everyone. Yeah, the net present value for nickel mine, is higher if we estimate the net present value project using benchmark price in 2026. Yeah, unfortunately, for smelting industry, if we use the nickel ore price using newest regulation, minus. So this is the impact. Even though the government take not so much different if we use new or previous regulation. So this is the situation in our country. So if smelter have higher costs on their raw materials, I think the project somehow will get a negative value. That's why government need to consider or give the any other advantage, yeah. Because if the smelter is closed or temporarily closed, there are so many disadvantages, yeah. Labor will not work, yeah, and the supply of any other raw material for smelter, let's say the agricultural product consumed by worker labor in smelter will stop, yeah. That's why many multiplier effect will stop if the cost of raw materials become higher due to the newest regulation. Okay, and then as a discussion, the strategic response of nickel mine. I think nickel mine need to treat geology as a pricing strategy, improve grid control, moisture management, and ore blending, because this factor increasingly map into the benchmark value. And then strengthen downstreaming optionally. Yeah, smelter need to build the strategic partnership with the nickel mine. Let's say we can use tolling strategy. Yeah, the ore owned by the company or nickel mine, and then the nickel mine will pay the treatment charge and refining charge to the smelter industry. So with this strategic partnership, I think the economic benefit of a smelter will get increased. And then rebuild fiscal models, yeah, separate benchmark-based levy assumption from realized price assumption to avoid overstating free cash flow. And then as a closing remark, I will, we need to focus on both aspect, positive policy impact, yeah. for this kind of regulation. First, improve transparency in price formation, support domestic value addition, and protect state revenues through benchmark price fiscal reference. But this policy also have challenge. Yeah, regulatory change can weaken investment confidence. In case of nickel, new reference price possibly reducing economic benefit of nickel smelter. So strategic partnership have to start between nickel smelter and nickel mine. And then the last, competitiveness can be affected when benchmark price differs from market accepted index. I think that's all my presentation. Thank you very much for your kind attention.
Okay, thank you very much, Dr. Fadila, for your insightful presentations about the current condition of our mining and smelting industries. So now we have 10 minutes for question from the audience. So if you have any question, please raise your hand. Okay, silakan, please, Pak Haris.
Thank you, Mr. Fadila, for the interesting presentation. My name Haris Nurika Prastia, master student in mining engineering at ITB. Recently, RKAB has become a hot topic in Indonesia as government adjusts production quota and balance supply and demand and stabilize commodity price. At the same time, the benchmark price regulated by HBA and HPM. My question is how significant the impact of RKAB restriction on commodity price? And my second question, can we now consider that RKAB as an direct instrument for commodity price management? Thank you, Pak.
Okay, the first question regarding the supply demand, is it?
Yes.
Okay. Coba di apa slide-nya. If you don't mind, the operator, could you show my slide presentation so I can explain more clearer to the Mr. Haris and also all audience. Okay, everyone, we can take a look in this benchmark price formula. In this HPM, or we can call it nickel ore price. Yeah, nickel ore price will affected by the HMA. HMA in Indonesia defined as London Metal Exchange price. Sometimes London Metal Exchange used as a reference for HMA. Unfortunately, the market of nickel ore in Indonesia, the supply demand of nickel ore in Indonesia is not affected by the world nickel supply demand. Both market is major. If the market for nickel, world nickel metal, and also nickel ore in Indonesia is major, there is no impact. The market will move differently. That's why sometimes there is no correlation between ore price in Indonesia and nickel metal price in the world. If the nickel price according to London Metal Exchange getting higher, maybe possibly that the ore price in Indonesia not follow the higher price, because the system of supply demand between ore in Indonesia and metal in the world is different. So sometimes the gap between the realization of nickel ore, the gap is a little bit high between the this price derived from the formula with the actual transaction price in the market. Yeah, yeah, that's the situation in our country. And then uh, regarding the RKAB, yeah, the annual planning before the mine start to work in the next year. Uh, yeah, we need to take a look on the assumption of each nickel mine when they mm, report their RKAB. Somehow the assumption will different with the realization. Uh, in most of case, forecast price will different with the realization price. So, in my opinion, RKB maybe could not use as a control for the nickel ore price itself. That's my answer, Pak Tommy.
Pak Haris, do you have any follow-up question? Okay. Okay, so now we move to the next questions. Does anybody have question for Dr. Padilla? Okay, maybe while we are waiting from the audience, so I have one question. So the new regulation about the price has been applied in this since March this year.
Yeah.
And based on your model, the smelter will have negative impact.
Yeah.
Yeah. So after one semester, could you please tell us what is the real situation in our smelting industry?
Okay, thank you, Pak Tommy. In the short term, yeah, we can define short term as 1 year, 2 year, or three years consecutively. For nickel smelter, they have their contract with the nickel mine, which is not affected by the new formula, Pak Tommy. So their contract has, I think the contract will apply until the end of its contract. So the impact of this new formula maybe we can find it in the long term. Yeah, every smelter, I think, how to say, we cannot make a similarity between smelting industry with the shoe industry. Yeah, for shoe industry, we need the leather. We can buy the leather as a raw material every month, every 2 months, every 3 months. It's okay. But for the smelting industry, they need to keep the supply of ore maybe around 1 year or 2 years. So we can find the impact, the real impact, not in the short run, Pak Tommy, but in the long run of mining and smelting industry.
Okay, so now the audience, do you have question? Okay, so maybe just one more question. Now I'm looking at from the mining side. So let's say they have contract with smelter at certain price, and that price is actually not affected after until the contract completed. And what about the obligation they have to pay to the state, like royalty or taxes? How they calculate it?
I think, Pak Tommy, even though the contract available have a lower price, but for the tax duty will follow the higher price. That's yeah, how to say, our country needs money for many purpose of our president.
Maybe we can say that in the short term, maybe the mining.
In the short term,
Yeah.
mining and processing industry is okay. The effect is not so heavy, but in the long term, we can take a look the impact.
Okay, thank you very much, Dr. Fadila, for your presentation and for your time for discussion with us today. So yeah, I hope that this session will give uh, many benefits for the participants who come and attend this session. So now I return the session to the MC.
Thank you very much to Dr. Fadila Ahmadi Rashid for such an insightful presentation and Dr. Tommy Alvin Rifai as the moderator. Please give a warm round of applause. And before we move on to the next session, we would like to give an appreciation to the speakers and take photo for documentations. For the speakers and moderator, you may come to the center of the stage. To the moderator, you may now give the gift to the speakers. Okay, once again, thank you so much to the speakers and moderators. Thank you. And now we will continue to proceed to plenary session 5 on sustainable technology solutions. And our speaker is Muhammad Haryadi Setiawan, Director of PT Lapi ITB, and there will be Dr. Donasita Ambarsari for the moderator. To Mr. Muhammad Haryadi Setiawan and Dr. Donasita Ambarsari, please you may come to the stage and the session is yours. Thank you.
Okay, good morning everyone and welcome to the keynote session with the topic Sustainable Technology Solution, and I will be the moderator in this session. And this session will be presented by Muhammad Haryadi Setiawan from PT Lapi ITB. Maybe I will explain about PT Lapi ITB shortly. PT Lapi ITB is a business unit of Institute Teknologi Bandung, established in 2004, and it provides professional service to government institution, state-owned enterprise, and national international private companies. Supported by ITB's expert, lecturer from ITB, laboratory facilities, and network, PT Lapi ITB play very important role for applying research and innovation in science and technology. And I will explain about a profile of Mr. Muhammad Haryadi Setiawan. Currently, Mr. Haryadi is the director of PT Lapi ITB, and he was experienced business enable specializing in agribusiness, food industry and social business, and sustainable development. And the education, previously he graduated from Geophysical Engineering, FTTM Institute Teknologi Bandung at in ITB, and then he was project manager at PT East West Seed Indonesia, and then he was program manager for Horticultural Partnership Support Program, Indonesian Netherlands Association. And now currently he is the executive director of Sinergantara. Okay, to give us deeper insight, I will now to return the time over Mr. Haryadi, and you will have about 20 until 30 minutes, I think, to give your presentation. Okay, Mr. Haryadi, the floor is yours.
Thank you, Donna. I'll be just standing here. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. Distinguished colleagues from FTTM, Faculty of Technology, Mining and Oil in ITB, also other participants in this particular interesting and challenging event, ICGERE. I would like to presenting some portfolio that managed by PT Lapi ITB, as mentioned by Dr. Dona before. PT Lapi ITB, I will briefly introduce you about PT Lapi ITB a little bit deeper. After that, and briefly, I will presenting a portfolio, some portfolio that relate with the topic of discussion today, sustainability and geoscience and technology. And a little bit deeper later, I will also elaborate some cases that maintained by PT Lapi ITB to serve the mining sectors as well as energy sectors in Indonesia. Okay, next. Oh, I can switch from here, right? Okay. Okay, this is PT Lapi ITB. PT Lapi ITB was founded by ITB since 2004. It's been like 22 years from now. And we call ourselves as a STEAM-based solution provider. STEAM or STEAM is Science, Technology, Engineering, Art, because in ITB that we have like Faculty Art and Design, and Math and Management, because we also have School of Business and Management. So we combine three resources of ITB. First is talent. Secondly is knowledge and network owned by whether it is ITB or the alumni or even beyond the talent from beyond ITB that we also recruited. And then we combine all the resources with the facility owned by ITB, such as laboratory. We have more than 200 laboratories in ITB. And all those three particular resources we combining and serve and deliver as a solution to the public in different sectors. So our services consist of three major products as well. First is consultancy. It is arranged with studies, detailed engineering design, all different type of consultancy. The second type of services delivered by PT Lapi ITB is human capital development. And the third one is technology services. Maybe in this opportunity, I will a little bit explore on the technological services part of our services. And we have, because as I mentioned before, our core talent is lecturer, researcher from ITB. We have more than 1,000 talent within ITB, but not everybody in ITB also have a keen to be a project associate through LAPI, but at least more than 300, maybe like 500 lecturers, researchers from ITB is become our associates. And we already manage more than 1,000 projects since 22 years ago. And now we have serving more than 400 clients and partners. And this is particularly our services with regard the energy and mining sectors. We do some general research, exploration, mining, and development preparation. And mostly of this particular services or solution is delivered by our talent from FTTM. Some of them also available here, like Dr. Tommy, Dr. Fadila, that been presenting before, is some of our associate in LAPI ITB. And this is the other type of services. So we can call all along the value chain of mining sectors or natural resources, LAPI have a portfolio to serve the services. And this is particular subject that I've been asked by the committee, organizing committee to present. So we have several cases or services that deliver to several client in the presentation below, like PLN, Antam, Pertamina, you name it. Almost every energy and mining company in Indonesia, whether it is pure private sectors or state-owned enterprise, or even in the international sector, such as last year, as until this year, we also serve Oil India. It is like a Pertamina-nya India. We also serve a Brunei Darussalam government in different type of solution with regard the geoscience and technology. So we provide this type of services: tailing mine waste, water management, land soil protection, climate and decarbonization, environmental risk, sustainability. Some of them has been mentioned or elaborated by Pak Hengki on yesterday session. We have a really deep. Oh, why it's not coming? Oh, should content here? Oh, there. Nggak bisa ini ya? Pointersnya. Oh ya. Okay. I thought it was like a lesser pointer, no? Okay. Like this. This is highly explored now with Center of CCUS in ITB. So in each faculty in ITB, we have like a center, which is consists of multi-discipline and multi-background expertise in ITB. And PT Labi as a commercial vehicle of ITB align and collaborate with this particular center and create a program and delivering to the client as they need it. We do like a different approach, integrated approach, such as data investigation, analysis, modeling, evaluation, decision making, implementation, and technical support. And for the time being, we have more than 300 projects under this particular scope. And this is another thing with regard also topic that rising rapidly in Indonesia with regard disaster risk mitigation. We also combining expertise from geoscience, from civil, from physics, and also from like what you call it apa namanya meteorology. It's particular part of FITB actually in ITB, but it is also geoscience, and we deliver also different type of services such as hazard assessment. For example, there is big what you call it compound or perumahan itu apa in English, like housing complex in Bandung. They ask to give some insight on the possible hazard with regard that can give risk to this complex of residential area in this client. And we combine different expertise to help them to like make a prediction based on the historical data as well as a future projection of possible risk, disaster risk on this particular residential area. And with this particular project, we have more than 120 different portfolio, yeah. And I would like to elaborate a little bit more. This is also part of innovation that developed by PT Lapi associates. We call it our subject matter expert as associate, which combining between a different type of expertise in physics, electronics, and information technology, and working together with one of our client, mining contractors. They asked us to jointly develop a solution for their fleet management system. So it started back to 2008, I think, like almost 20 years ago, with a small scale prototyping. But for the time being, we call it collision avoidance system, has been implemented successfully and expandedly in different especially coal mining facilities in Indonesia. So this CAS, it is combining between instrument, IoT, Internet of Thing, and we collect all data that put in this type of vehicle or fleet. If I think some of you have been visiting mining site, they're working with big mode of transportation, and each of those particular devices or fleet has to be connected, has to be communicated. Before we implemented the CAS, mostly they work like a little bit manually. So it is a risk for them to have a collision in the intersection or in between the mode of the fleet, the very big fleet, they can have a risk of collision. So we install this equipment, this type of equipment. It is designed, prototyping, and manufactures purely by talent from ITB, Associate of PT Lapi ITB, and we have workshop nearby here in Surapati, Bandung. And it is installed both in the vehicle as well as in the room, we call it war room. And because it is IoT, it can be monitored in the headquarters of those particular mining contractor in Jakarta. So when I came to their company, we visit quite brand new facility. They call it like a digital war room, and all over the wall is monitor. They can monitor every single mining activity in different area, with this whether it is in Kalimantan, Sumatra. They can monitor and utilizing this information to organize the fleet and then ensuring that there is no collision among one another. So this is the feature that CAS developed. It can also do a proximity detection system, which is one and another fleet can communicate and can avoid any, maintain the distance. And secondly, they have like a fatigue alert system. It's combined with some indicator or sensor that can give alert to the driver. Because if we talk about sustainability, it's not only about the financial aspect of the business, but also how we manage the people that working on that office or on that business to be safe. And safety is one of single or even main indicators that become more common or more important in the mining business. This is also mine awareness, fleet management system, and collision avoidance system. This is combining between different type of features that install on this particular equipment. And we also working on this different direction of this particular technology, because we think that this quite interesting, and we start to promoting this implementation to other company in mining sectors. So I think for the time being, that's my brief presentation. So again, sustainability is not also a matter of appreciate the talent or the people in the business, and it is beyond profit. I think that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Okay, what an insightful talk from Mr. Haryadi. And we open the Q&A session from the participant. Please, if you want to ask something to Mr. Haryadi, please raise your hand. Okay, okay, one question.
Thank you, Pak Haryadi, for your presentation. So you mentioned about people and also PT Lapi Associates, and most of them are lecturers at ITB. So I think maybe there is one another advantage of PT Lapi is that PT Lapi is like a place for students also to enhance their skills. And also PT Lapi is, I think I can say, is one of the backbone of ITB. So ITB can deliver the best of quality in their education services. So could you please tell us about that? So yeah, maybe we can hear more about it.
Thank you, Dr. Tommy, for reminding me one of the also important function or roles of PT Lapi ITB. So as mentioned by Dr. Tommy, PT Lapi ITB is also a kind of hub or talent development ecosystem, we call it. Because in PT Lapi ITB, we engage with different type of talent, whether it is coming from internal lecturer or researcher in ITB, but we also engage with the alumni even beyond ITB. We also recruit talent from different university because we need also different type of roles and expertise. And addressing Dr. Tommy question, I came here with two our new or fresh talent from ITB. Please stand up. And on the right with the blue is Halda. Halda is graduate from geophysics engineering, so my junior, our junior, from geophysics engineering year 2020, and Rani is graduate from geological engineering year 2020. So both of them just been recruited freshly after they participate in the Magang Hub. If you aware, maybe our student or adik-adik, if you aware, there is a program managed by Kemenaker, work labor ministry that call it Magang Hub, that give opportunity for fresh graduate to jointly internship, paid internship by the government for 6 months. And we just received last year like 25, I think Halda, 25 internship from different university. Even some of university I didn't recall because it's just knew it from this. So we recruit 25 different internship, whether it is in project management, in IT, financial, legal, and some of them work for 6 months, and some of them now been recruited by PT Lapi ITB, becoming our permanent staff, like Halda and Rani. Now they become like junior project assistant. They are both working. Rani is working for energy sectors. Oh, sorry, mining sectors. Halda working for energy sectors. And we have, I think, FTTM is one of the faculty that contribute about 30% of portfolio under PT Lapi since last 2 years. So there are many interesting project asked by our client, whether it is private or state-owned enterprise or even government or even for abroad or foreign entity. And 30% of them is coming from mining sectors and maybe 10% or 20% coming from energy sectors. So I invite, also ask two of them to join us because they will also give some example to everybody. So everybody, like young talent, would like to also join to PT Lapi ITB. We are very welcome to welcome you, and you may join us whether it is as an internship or maybe join in the project that we organize. I think that's my response. Thank you.
Okay, thank you, Mas Tommy. Mas Hari. Boleh. Yeah.
Actually, I made some revision, putting one slide. Next. Oh, I can switch on from here. This is also a new type of solution. Oh, no. Kan yang terbaru ya?
Yang Mas Hari terakhir. Ya, itu.
Yang tentang tailing belum ada ya?
Yang Mas Hari kirim ke saya.
Sorry, berarti salah kirim ya?
Oh,
okay. It's okay.
It's
Then
okay.
I made some additional slide. It is talk about what now become also very much relate with our discussion. We call it dry stack tailing management. So it is initiated by our talent from FTTM, especially Dr. Irwan Iskandar. And from his research, his ideas, dry stack tailing management now become one of major hot topics and hot services that request by mining sectors in Indonesia to be delivered by our talent from ITB. So the essence of this dry stack tailing management is managing the tailing from the smelter, especially HPAL smelter that consists so many water. Usually, previously they built like a big dam or big pond or big, yeah. There is a Dr. Tommy here. If correct me if I'm wrong, Dr. Tommy is part of the team. So previously, the mining company built a very big infrastructures like a pond, and they what you call it deliver all the tailing that consists of water into those particular infrastructure, and it is consists of different type of risk because we deal with very huge amount of byproduct. We call it. We didn't call it waste because we call it byproduct, and it is have many risks in terms of the geotechnical risk, environmental risk. So Dr. Irwan and his team, including Dr. Tommy, come up with the ideas to make dry stack tailing. So instead of in watery or a little bit like a sludge, it turned into dry uh, tailing with, so it come into like a filter and manage the water into different type of processing. And environmentally, from the point of view of environmental, it is more green, in my opinion. So if you read about sustainability issues in this geoscience, one of the point that become addressed on this particular discussion is about dry stack tailing management. And in Indonesia, our talent from ITB has already been delivering this type of service for so many mining industry in Indonesia. I think that's a real contribution for our talent here, and giving some innovation and giving some improvement on the way of mining sectors manage their business. That's the point. Thank you.
Okay, thank you. I want to ask one question, Mr. As PT Lapi ITB act like bridge with academia, researcher, and industry, and what do you see the condition now for geoscience evolve for meeting the industrial needs and then the demands of the net zero sustainability over the years, like situation now of the geoscience evolving for the net zero mission and then the industrial needs. What do you see?
Yeah, I think also addressing some point that already developed by Pak Hinggi yesterday, such as new area like CCUS, carbon capture and utilization. There's also growing demand, and there is a lot of needs for geoscience or talent to involve on this particular subject, but also other type of development or project needs knowledge and needs expertise from geoscientists or geoscience engineering. For example, in the issues of disaster risk reduction, we deal with so many infrastructures. For example, this year, I think start from last year, we engage with BPDLH, Badan Pengelola Dana Lingkungan Hidup. It is organization managed by Menteri Keuangan. They have like a fund to initiate research on risk of infrastructures according the climate change. If you understand, before there is a climate change issues, people in geotechnical or civil engineer design infrastructure without considering those particular changing or environmental or climate changing. And this research led by Dr. Irwan Melano, our vice rectors, try to observe different type of infrastructure in Indonesia and see whether any particular indicators that can be examined, and it will be impact in terms of business insurance or infrastructure insurance. So this type of knowledge is also important for even for financial sectors. Dr. Fadila previously also gives some insight how mining economics also gives some insight on the economic or financial, but also understand better understand about the impact of the climate change, also giving some insight to the insurance sectors in Indonesia or abroad. So that's the type of particular sector that maybe during now or like now not really become major concern of our student, but it's going to be more needs from geoscience and engineering in the different type of project. Thank you.
Okay, thank you very much, Mr. Hari. And maybe another question from participant?
One thing
Okay.
maybe I can add, Donna. I was working mostly in food industry and agribusiness sectors. And when I was working in one of Netherlands company, we manage hectares of vegetables and fruit, mostly vegetables, plantation and research development field. And that time we need to find a more efficient way of taking sample or soil sample and analyze in the laboratory. And at that time, back maybe 10 years ago, I heard that there is a research in technic geophysical engineering in ITB, led by Professor Satria, yeah? And he just developed a new way of screening the soil using georadar. I came to my department in ITB, and I didn't notice before that there is a new frontier of what they call it geophysics in agriculture. Even there is a book written by expert in United States and become like a textbook for geophysics or agro geophysics. I forget the title of the subject. And that's going to be also a new frontier for geophysics or geoengineering or geoscientists in agribusiness sectors. Recently, we are also collaborating with graduate from SITH, from School of Ilmu Teknologi Hayati, Life School in ITB, as well as from FITB, graduate from Geodetic. They built a startup company called AgriVision, combining between knowledge on geospatial and knowledge on biology. So what the product is quite interesting. They use a drone to scanning the the soil and the vegetation in the plantation area. From that particular scanning using drone, they can measure the level of ability of soil and vegetation absorbing the carbon. And they're working together with other talent from Malaysia that producing fertilizer. This fertilizer is implementing or applied on this particular plantation. In this case, it's coffee plantation, and they can measure the impact of the soil and the vegetation in absorbing the carbon. So what is their business model? Their business model, this is AgroVision is also our new startup. They try to sell this gap between the absorption as a carbon credit. So it is also a new way of business. And it is initiated by our young talent from ITB. And we engage with them. We jointly develop a proposal, submitted to the BBDLH. But unfortunately, we didn't grant it for the time being. But I keep contact with this group, a small group of graduate, and we keep eager to promote this innovation because I think this is going to be new way of people doing business in the future, measuring their business contribution in absorbing carbon. Thank you.
Thank you very much for such an interesting session from Mr. Haryadi. I think that brings our Q&A session to an end. So maybe I will give it back to MCs. Okay.
Okay, thank you very much to Mr. Muhammad Haryadi Setiawan for such an amazing presentation, and also to Dr. Donasita Ambarsari as the moderator. Please give a warm round of applause to the speaker and also the moderators. And before we move to the next session, we would like to give an appreciation to the speakers and the moderator and the speakers. You may come to the center of the stage. To the moderator, you may give the gift to the speakers. Okay, once again, give a round of applause to the speaker and the moderators. Thank you so much. Ladies and gentlemen, we will now take a 10-minute coffee break. Please return to the main hall by 6:10 and for plenary session 6 on geothermal engineering. Please enjoy the break. Thank you. Ladies and gentlemen, this is a gentle reminder that the session will begin in 3 minutes. Please return to your seat. Thank you. Welcome back, ladies and gentlemen. We will now begin our plenary session 6 on geothermal engineering. Our speaker will be Mr. Dimas Taha Maulana from Geothermal and Petroleum Drilling and Production, Geothermal Engineering Institute Teknologi Bandung. And to moderate the session, please welcome Ms. Fauzia Maswa. To Ms. Fauzia Maswa and Mr. Dimas Taha Maulana, the session is yours. Thank you.
Tes. Okay, thank you very much, MC. And Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, dear participant of the International Conference on Geoscience and Earth Resources Engineering 2026. It is my great pleasure to welcome you to plenary session 6 with the theme Geothermal Engineering. And my name is Fauzia Maswa from Geothermal Master Program ITB, and I'm honored to be your moderator for this session. So in this session, we are proud to present an outstanding speaker. Today we have Mr. Dimas Taha Maulana from the University of Manchester, UK. So please give a round of applause to our speakers. And thank you very much, Mr. Maulana, for your time. And before we proceed to the presentation, let me explain about the question and answer session. So the Q&A session will take place after all the presentation concluded. And if you have a question, please save and note them until the Q&A session. And during the discussion, please mention your name followed by your institution before asking the question. So before we begin, I would like to introduce our speakers. So Mr. Dimas Taha Maulana is a senior researcher and lecturer with the Geothermal Engineering Research Group at Institut Teknologi Bandung, where he also earned his master's degree in geothermal engineering. He is currently undertaking his PhD in chemical engineering at the University of Manchester, UK, where he previously served as a graduate teaching assistant. And today, Mr. Maulana will present well-bore multiphase flow analysis and modeling for a multiple feed zone competing geothermal well. So, Mr. Maulana, you have 30 minutes for the presentations, and the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. As the moderator said before, that my presentation is gonna be like about couple between wellbore simulation and reservoir simulation. And currently, I'm a PhD student in University of Manchester, and this research also supported by PLN and also Dikti Scientech from LBDP. And this is my presentation title, which is wellbore multi-phase flow for analysis and modeling for multi-phase feed zone combating geothermal well. I apologize if this presentation gonna be quite technical compared to the presentations before, because this is part of my PhD research. And this is the background why the couple between wellbore simulation and reservoir simulation is important. For you that has no background in reservoir or wellbore simulation, so the reservoir simulation is, you know, how to perform or how to simulate the flow inside the porous media in the reservoir. You can say that for geothermal or for oil and gas, we need that reservoir simulation to perform like how big the resource that we can get or how big the oil or gas that we can produce to the surface. That is reservoir simulation. And for the wellbore simulation is to simulate how the fluid perform from the bottom hole to the surface. For example, how its pressure change, how is the phase change, and so on. So why it's important to couple between those wellbore simulation and reservoir simulation, because usually we only believe on the reservoir simulation. For example, we do a simulation at the using reservoir simulator, and we get like how big, for example, in geothermal, how big like mass rate, how big the pressure, how big the enthalpy, but we ignore about what happened if that fluid going up to the surface. Yeah, obviously the pressure is changed, the temperature is changed, the phase is changed. If we assume that it's only simple water, imagine if we use it in oil and gas, which is where is the fluid is not only, the liquid is not only oil, but also gas, also water, and sometimes there is like CO2 or something like that. And imagine if we use it for simulates the CO2 injection, for example. Obviously, the parameter of the fluid is going to change from surface to the subsurface. And also, for example, if we produce like geothermal brine, which has a lot of CO2 or a lot of NaCl, for example, the phase or the parameter of the fluids, yeah, obviously change during the simulation. That's why these three reasons why the couple between wellbore simulation and reservoir simulation is important. The first one is, of course, when we produce or we simulate production. Oh. Yeah. I pressed the wrong button though. So, for example, if we, as I said before, if we simulate like production from the reservoir simulation only, we neglect like the change of pressure, the change of, yeah, of course, the more important is the change of pressure. So we assume that even sometimes, if you assume that it's produced from the reservoir simulation, the pressure is not coming out to the surface. For example, the pressure is too low, or the enthalpy is too low, and then that production from the reservoir simulation is not really produced in the surface. Yeah. And then the second one is, yeah, as I said before, that the fluid parameters is changed. For example, yeah, in geothermal, we assume that it's only water. It has no, usually we assume that it has no CO2 content, it has no NaCl content, and so on. So we assume that it's only water. That's why the only parameter change during the wellbore from the subsurface to the surface is only pressure change. Sometimes we assume that the temperature is remain constant, the enthalpy has remained constant. But in the reality, in the theoretically, it should be changed during the flowing from the downhole to the surface. And then sometimes the operator is also make, for example, at the surface, the pressure is constant because they consider about the input pressure at the turbine, you know. So for example, the turbine for the inside pressure is 6 bar. So if you track down to the wellhead, the wellhead should be always above like 15 bar to operate. So imagine if you only use the reservoir simulation to simulate the pressure at the reservoir, the pressure obviously going to decline, right? Because of we produce the water. If the pressure is declining at a certain point, if we simulate to the surface, it will be less, for example, than 15 bar. So in couple simulation, you can adjust for the wellhead pressure should be always 15 bar, and then you need to track down to the downhole and then change the parameter at the reservoir simulation as well. And this is the milestone of research in couple between reservoir and wellbore simulation. This first, the same problem with before. The first milestone is about where when the wellbore simulation is used in reservoir in a geothermal field is only so between the reservoir and the wellbore simulation, both 1985 from Hagedorn Brown and Grant Bixley and Hadju et al. They have done reservoir simulation and wellbore simulation and disparate simulation. So the result from the reservoir simulation, the production, as I said before, used as an input for the wellbore simulation. So it's not integrated each other. So for example, the research that is done by Pan et al. And Gudmund Sotir, they done the iterative simulation. So first they run the reservoir simulation, and then they got like a production estimation, and then they put in a wellbore simulation, and then the result from the wellbore simulation use again and the next time step to adjust the parameter at the reservoir simulation and do it so on. And this one is the methodology that I did for my research. And in 2015, for example, the research from Pante et al. And Battistelli, they did the wellbore simulation and reservoir simulation as one simulator. So the wellbore simulation is part of the reservoir simulation. Yeah. And then the 2020 and so on, and the next current research, they did this couple wellbore simulation and reservoir simulation for another application besides oil and gas and geothermal. For example, here, as I mentioned before, is it important to simulate like how CO2 produce? Yeah, in water we only consider like pressure, temperature, and enthalpy, right? But for CO2 we also consider like pH, which is very important. So when you design for the, for example, in a drilling, you design the casing materials. So you need to consider like when is the pH change during the along the wellbore, for example, like that. And then the current research also combine not only wellbore simulation and reservoir simulation, but also combined with another simulator, for example, chemical. Yeah. And this is example of the application for the couple wellbore simulation and reservoir. It's not only in a certain field, but it's also applicable for a lot of fields around the world. Yeah. And this is my research. I try to exercise this methodology to a field in Indonesia that has 2 feed zone. And so in geothermal, just for your information, in geothermal we usually not only have 1 feed zone as production zone, we also like have a multi-feed zone, for example 2 or 3 feed zone that each has like a mass rate to produce to inside the wellbore. Yeah, this is one of the example of a well that has multi-feed zone. Sorry, it's not really seen sharply, you know. Yeah, you can see here, this is the well, and it has one feed zone here, and then the second feed zone here, and the third feed zone here. So it's 3 feed zone with multi-phase. So from the bottom here is water, and then this is water, I mean liquid, and then the top one is steam. Yeah, so it's multi-feed zone and multi-phase as well. That's why that's make this simulation gonna be quite complicated. And then this is the production story. You can see here that is the red one is steam, and the yellow one is wellhead pressure, and then the blue one is the brine production. So when the operator try to change the wellhead pressure, they decrease the wellhead pressure, the production became like, it's called cyclic or competing production between the steam and water. So you can see here that it's became oscillating, you know. It's hard to analyze. And this is the this is the parameter. You can see here the depth of the feed zone 1, the feed zone 2, and the feed zone 3. And this is the methodology. So I tried to do 2 approaches for the couple between the wellbore and the reservoir. The first one is, I said it's sequential coupling. So I did the reservoir first, the reservoir simulation first, and then all the result along the time of simulation, for example, for 1 year, I capture the result, and then I do the wellbore simulation. Yeah, so it's not iterative, it's did one by one. And then for the second simulation, I did iterative explicit coupling. So I did one time step, for example, 1 day for the reservoir simulation, and then I did the wellbore simulation, and the result of the wellbore simulation affecting the reservoir simulation, yeah, so on, until 1 year. So I did iterative for 1 day, and then until 1 year simulation. Yeah, and this is the detail of the calculating that I did, or simulation that I did. And this, for the first time, I need to validate my wellbore simulation first. So this one is 2 data that I got from the field, and then the line is the simulation, and the dot is the data from measured from the field. And you can see here that is the wellbore, and the data is, yeah, it looks like it's not really much, especially for the lower pressure here. This one is the higher wellhead pressure, and this right one is the lower wellhead pressure. Yeah, it's difficult to make it much for the right one, because it's, you can see here, the right one is this condition, yeah, the cyclic condition, and then the left one when it's in the steady condition here. And this is the reservoir simulations. Oh, I need to validate as well. I use the research from my colleague, Pak Sutopo, yeah, from geothermal engineering, and Hamad. Hamad is the student as well from geothermal engineering, right? I think from oil and from petroleum engineering. So I did the reservoir simulation, only sectoral, so it's only small reservoir simulation actually, but the grid is smaller, so to make the resolution higher. So the reservoir simulator from Hamad and Sutopo actually is a big reservoir, but for my research, I only focus around the well with higher resolution. Yeah. And this is the result of the reservoir simulation. It's, yeah, we thought that it's much enough with the real data. So the line is the data. Sorry, the dot is the data. It's a dot. And then the green and the yellow line is from the simulation. Yeah, it's much enough. And then I tried to do this both sequential simulation and iterative simulation. Both is quite following the data. The black one is the data. For example, this one is for wellhead pressure and this one is for steam mass rate. So the both wellhead pressure and steam mass rate is following the data. You can see here. Yeah, but something that I want to say is the iterative is much more following the data rather than the sequential. The sequential is the blue one here. You can see it's cycling, but it's not following the data. Yeah, as well as the steam comparison. So after that, after I assume that this simulation is following the real condition of the field data, and then I try to do forecasting with two conditions: high pressure and low wellhead pressure. Yeah. So the blue one is for high wellhead pressure, and the red one is for the low wellhead pressure. So you can see here that for the low wellhead pressure, the wellhead gonna be 0 in around 200, yeah, below 300 days. And then for the high wellhead pressure, the rates remain, yeah, it's still 8 bar in 1 year. Yeah, and then I did the sensitivity simulation to address the uncertainty in this simulation. So for example, I did the simulation more higher resolution. For example, I changed for each 1 day into it's 10 day into 1 day. So the result is not quite significant change. It's almost the same. So I can say that, yeah, of course, if you reduce this time step, your simulation gonna be longer. Yeah, for 1 day, it took like 12 hours with high spec of computer. For 1 day, it's gonna took like 2 days until the simulation finished. So it took in UK we really consider the time because time is money consumption. Yeah. And then I changed the probability as well for the reservoir because we don't really know what is the probability actually. So I changed and this is the result. Yeah, of course, if the probability is higher, the productivity will be increased as well. And for the wellbore parameter, I try to change the diameter of the casing. Yeah. In case the casing is reduced because of the collapse or this mineral scaling. And this is the result. It's really affecting the wellbore simulation. For example, if the diameter casing lower 10%, you can see here, this is the base, and then this one is lowering 10%. It's decrease, and also make the wellhead becoming 0 before 1 year simulation. Yeah, I think to sum up, this one is the conclusion. Yeah, the first one is that OLB01 can be reconstructed using PTS. I mean the wellbore simulation, validate with the PTS data, and then low pressure operation promotes feed zone competition. Yeah, of course, we can see it from the data. And cooler inflow around the intermediate feed zone when I operate the well in a lower wellhead pressure. And then the iterative coupling provides the best match for wellhead pressure cycling. And then the forecast indicate that if we use or operate the well in a lower wellhead pressure, the flow gonna be, or the wellhead gonna be 0 in a certain time. And then the sensitivity confirms that wellhead pressure is more uncertain than enthalpy and depends strongly on permeability and casing inner diameter. I think this is all my presentation. I hope you can follow it. Okay, thank you so much.
Thank you very much, Mr. Maulana. Such interesting talk. And now we are moving to the Q&A session. So if you have a question, please raise your hand. Any questions? Okay, please. Please mention your name, followed by your institution.
My name is Amzul Fikri. I am from Chemical Engineering at University Dhamada. I just wondering, based on your research, you're modeling reservoir and wellbore coupling at sectoral scale. Now that is it possible the result from the coupling wellbore reservoir simulations from this sectoral scale can be integrated to field-wide scale to simulate the reservoir as a whole field? Thing is.
Yeah, I need to repeat the question is that because I use only the sectoral simulation, which is only like 1 kilometer radius from the well. So is it applicable to simulate it for the big field, for the real reservoir simulation for the big field, right? So yeah, is it possible? That's actually I did it before I focus on the sectoral model. But the problem is, if we do the simulation for the big model, it took a long time, right? For example, I forget. I think it's like 1 day for one run, which is very wasting time for me. So I only where I only focus on the well. And also, we have no data actually to validate what happened in the big field, since this field is only have the well focusing on a certain area. Yeah, so it's Olombo field is they only drill in a and that time they only drill in a one well path, which is only in a certain area. That's why I don't have data for the huge reservoir. Yeah, yeah, I need to reduce the time, and I don't have the data. That's why I just assume that the rest of the area for the reservoir, I assuming that is the same. I mean, the homogeneous reservoir. For example, I just put the same probability, and I only put like the big volume for the boundary at the reservoir itself. So it's pretend like a big volume of the rest of the field. You get it? But it's not reduce the time simulation.
Actually, I have another one question. Why did you choose the rectangular grid block instead of radial model? Is it? I think it's better to choose a real model because it is more representative to sectoral wellbore simulation.
Yeah. Yeah, nice question. So in reservoir simulation, we can use not only rectangular, but we can use like radial as well. Yeah, actually I did it before for the radial, not for the um what is it? The other, I forget it. Yeah. So I did for the radial, but it's not represent the real condition. I changed to the square block again. But yeah, you can use it, but in my opinion, it's not gonna change any result for the reservoir simulation because the block is quite small. Yeah, and of course it's gonna be in reservoir simulation, the the as the much surface for each block that interact to another block, it will took a longer time. For the square, it's only like 6 surface, right? So it's only took like 6 time to do the calculation. But if you do like 8 surface or 16 surface, it took a longer time, right? The matter is that the block is quite smaller. Is it represent the change between the block? I'm sorry for the other, we're talking about the reservoir detail here. Yeah. So yeah, the matter is that is it representing your simulation or not? Doesn't matter about the shape because the matter is if the shape is as I said before, the much surface that interact with another block, it will make a longer simulation. I hope it's answered your question.
Okay, thank you.
Thank you. We hope it can answer your questions. Okay, next question, please. Okay.
Okay, I am Teresia. I want to ask, in the presentation mentions low wellhead pressure draws cooler fluid toward the intermediate feed zone. First, I want to clarify, does the intermediate feed zone refers to the middle feed zone among the three feed zones? If so, why is the cooler fluid drawn toward the feed zone 2 rather than the other feed zones? It is related to the pressure distribution and or reservoir connectivity around the feed zone 2 or what? Thank you.
Thank you. You followed my presentation very well, yeah. So you can notice that it's only 2 feed zone here. So yeah, actually it has 3 feed zones for this well, but the lower feed zone, productivity is very small. That's why I assume that it's combined to the second feed zone, the intermediate feed zone, which has a higher productivity. So so I simulate it's like only 2 feed zone, which is brine and steam. The important thing is that it's still multiple feed zone and multi-phase. Yeah. And then what is the second question?
Okay.
Huh?
No.
Oh yeah, yeah. The cooler influx water, you mean, right? Yeah. So I need to back. Oops. Is that? You mean this one? Yeah. So when this well operates in a lower wellhead pressure, it looks like something happened here. It looks like something like cold water going inside, right? So when I check it in the PTS, this one is the brine zone. Yeah, this one is brine zone, and this one is the steam zone. So the steam zone and the brine zone, it's like only 50 meters away from each other. Yeah. So I try to. Did I put it in my? Oh no. Yeah. I try to simulate this something happen here. So when it's lower wellhead pressure, there is water, cold water going inside to the wellbore. Yeah, I simulated as actually as well in the reservoir simulation. So that's why I put lower enthalpy here when the lower. So it indicates that the well is near the boundary. So there is like cold water coming from the outside, going inside the well. Yeah, but I address this issue in my simulation. Yeah.
Thank you. Could you please turn on the mic? We cannot hear from.
Test. So, is it basically because of the distance of the second feed zone or feed zone to the cool water boundaries?
Yeah.
Oh, okay.
Yeah.
Thank you, Mas.
Yeah.
Okay, thank you. Maybe any other questions? Okay, please. Seems like we have 100 questions.
Huh?
It seems like we have 100 questions from the audience.
Okay, thank you very much. My name is Reski Wirawan. I'm from Geothermal Master Program. Honestly, I'm exploration, but I'm curious about the iterative coupling method that you use in this study. So I just curious about the sensitivity of the iterative model dependency on the initial model. So we know it is iterative. So usually it is very dependent on the initial model that we use. And thus the method that you use is require an optimized initial model or specific algorithm to ensure.
Maybe comment.
Okay, I'm sorry. I will repeat my second question is, does the method that you use require an special or specific algorithm to ensure convergence, or just the iteration simply use the result from the previous simulation as the initial model for the next iteration? Thank you.
Bisa di display lagi nggak, Mas? Oke. Pertama apa ya? Kenapa? Just to make sure. What is your first question asking about what parameter that I need to consider for the iteration, right?
The how not just the parameter, but how dependence our result, our optimal result on the initial model that we use.
Okay, yeah. Yeah, here. Yeah, actually we can count in much parameters here for to the sensitivity, but this is for for student, okay? It's tips for you for the student. Anything that you are assume in your simulation or in your calculation, you need to do sensitivity analysis. So the purpose of the sensitive analysis is to give you a range for the parameters that you didn't have the data, okay? For the second one is to technically, and it sometimes, maybe we can discuss about it later, okay? Because the time is out as well, and the committee is quite
Okay, thank
strict,
you.
okay?
Okay, thank you very much. And for the interesting sessions. And of course, a huge thank you to all the participants for your active engagement. And yeah, unfortunately, our time has come to an end. If you have a question, you can continue to discuss with our speaker after these sessions. And on behalf of the organizing committee, I would like to express my sincere appreciation to Mr. Maulana. Thank you very much for your time. And now I return to Master of Ceremony. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much to Mr. Dimas Taha Maulana for such the excellent presentation, and also to Ms. Fauzia Maswa as the moderator. Please give a warm round of applause once more. And before we move to the next session, we would like to give an appreciation to the speaker. Please, to the speaker and moderator, you may move to the center of the stage. To the moderator, you may now give the gift to the speakers. Once again, thank you so much to the speakers and also the moderator. We now proceed to plenary session 7 on geophysical engineering. It is a great honor to welcome Professor Nick Rawlinson from the Department of Earth Sciences at the University of Cambridge. Unfortunately, Professor Nick Rawlinson is unable to join us, so he will present video by online video. So please enjoy the presentation.
Hello. So today I'm going to give a talk titled Earth Imaging and Microseismic Mapping in Iceland with Implications for Natural Hazard Assessment. And I would like to acknowledge my co-authors Esme Southern, Joe Phone, Jifei Han, Peter Jackson and Tom Winder, who helped prepare this work. Now the view you're looking at in front of you is across ICGERE caldera in the northern volcanic zone of Iceland. And it's about 8 kilometres in diameter, so very, very large. And the lake, or the crater lake in front of you, is called Oskavatn, and it's about 11 square kilometres in size, and has a depth of over 200 metres. And this was created in the 1875 Plinian eruption, and the broader caldera that you see was formed by earlier eruptive processes. And the photo was taken from the highest point of ICGERE, which is about 1.5 kilometres. And this view is looking back the other way, and this is actually taken in summer as well, after a snowfall. And you can see when the weather is beautiful, it's a very lovely place to be. So the overview of my talk is I'm going to start by providing a regional setting, so a description of the geology and tectonics, for those of you who aren't familiar with Iceland and the North Atlantic. I'll then provide a summary of seismic deployments that my group has undertaken over the last few years. And following that, I will then talk about 3 specific research areas. So the first being the Reykjanes Peninsula, ICGERE, and then Krapla. So this slide shows you the global and regional setting of Iceland. So on the top left, you can see a map of the Earth, and you can see it's a long way away from Indonesia. It's right up here near Greenland. And if we zoom in, we see that Iceland sits astride of the Mid-Atlantic Ridge, where we have the Reykjanes Ridge to the south, with its characteristic V-shaped ridges, and to the north is the Kolbeinsey Ridge. And basically, Iceland represents the terrestrial continuation of this ridge, and its existence is due to a large mantle plume that is providing melt from below, and this combines with melt from the ridge, and you get an extra thick crust, and hence you get Iceland standing out as clearly as it does. And so this slide here just shows you that a bit more clearly, that we have melt coming from this plume, the Iceland plume, and also mid-ocean ridge basalt melt, and this enhanced melting results in a crust some 4 to 5 times thicker than normal oceanic crust. So this slide shows you a map of Iceland, and these sort of orange zones that you see are fissure swarms, and they represent regions where there's active extension, and they often feature central volcanoes. And you can see that it's quite complicated. It's not just we have the Mid-Atlantic Ridge running through Iceland from one end to the other, and that's it. You can see it's displaced to the east. So we've had these sort of ridge jumps, and it produces these en-echelon volcanic zones. And in addition to that, to the north and the south, we have these transform zones, and what they do is help accommodate this displacement of the mid-ocean ridge. And the reason it's displaced is because the plume underlines Vatnajökull, which is this ice cap here you see in the southeast. It roughly underlies that, and so as a result of that, the plate spreading is focused in that region. And so these arrows I have superimposed over the top show you 5 different regions where we're doing experiments currently. So it's quite a lot of work, and I'll go through these in turn. So the first one is Snæfell's Nest. So this is the Snæfell's Nest Peninsula. You can see it sticking out to the west over here. And interestingly, it's not in a region of active extension, but on the top left here, you can see that there's been some recent seismicity. This is since early 2025, I think, or late 2024. There's been a lot of very deep seismicity, so just above the Moho. And as a result of that, we've put out an array of seismic stations, as shown here in the centre. It'll be very interesting to see how this swarm evolves. And already our early results suggest that it's there's a lot of seismicity down near the Moho, and there's some indication that it is also getting shallower as well, which may indicate that there's melt migrating up through the crust. This next slide here shows you all our stations deployed in the northern volcanic zone, and you can see here's ICGERE, and we have various stations deployed. In fact, some of these have been in place since 2007, so a very long experiment. And we also have stations extending down here to the southwest, to the west of the ice cap. And there's also a bunch of seismometers that over the last few years we've put up on Bundabunga every summer for a period of about 4 or 5 months to record local seismicity. And you can see that we've plotted underneath these stations relocated microseisms, and they track out the shape of the ring fault very clearly. And this ring fault is accommodating much of the reinflation that has been happening since it last erupted in 2014. So this is one of the bigger experiments we're doing in Iceland, and the fact that it's been out there for a long time has really helped us to understand how the region has evolved. So many of you may have seen in the news that the region that also includes Reykjavik, so the Reykjanes Peninsula, has had this new era of volcanism where there hasn't been any eruption for some 800 years, but in 2021 it was the first of a series of 12 eruptions that occurred and has dramatically changed the landscape of this region. And so we fortunately had an array of stations out about a year before the eruption started, along with some other groups, including the Czech Academy of Sciences, who we collaborate with, and you see all the stations superimposed here. And we also see these fissure swarms here in these separate volcanic zones that are sort of in this on echelon pattern. And the reason it's like that, if you look down here, you see we have the Reconnaissance Ridge coming into Iceland, but it's really trying to accommodate some of this eastward ridge jump, so it's essentially a transitional boundary, and so we have this on echelon set of volcanic zones. So we've had these stations in place from mid-2020 until now, recorded a huge amount of data, and I'll be talking about some of that later in the talk. And the final experiment that is currently underway is we deployed approximately 20 ocean bottom seismometers down the Reconnaissance Ridge across these V-shaped ridges. And the idea with this is to try and understand how mantle flows outwards from Iceland as a result of the Plume Ridge interaction. And these have been in place since September 2025, and we're about to pull them out in a few weeks, and hopefully we'll get some good data from that. Okay, so the first part of my talk is about the Reconnaissance Peninsula, and this is a zoom in of where we have our stations deployed, along with a number of other groups, including Geoscience and the Czech Academy of Sciences. And it's very interesting, I think, to superimpose the station locations over the road grid, because you can really see, and bearing in mind this is 5 kilometres here, you can really see how close the eruptions, so this was the first one in 2021 in the Fageralsfjord, that is very close. The international airport, Keflavik, is only some 20 kilometres away, and Reykjavik up here is some 30 kilometres away, so everything is extremely close. And then we have the fishing village here, Grindavik, which is almost in the midst of things. So an advantage is we can put out a lot of stations, and we can quite easily, because of the good road network, and it's very easy to access them. So recording all this data is very exciting and not that difficult to do. And so I'm just showing you a few field photos in the top left. This is our deployment of ocean bottom seismometers, where we use the Icelandic Coast Guard vessel the Thor to do that, down south of the Reconnaissance Peninsula. Up in the top right, we see the Fageralsfjord eruption in 2021, and here's one of our seismometers. We had to move it quickly so it didn't get overrun by the lava in the background. In the bottom left, you can see in the twilight the eruption of Fageralsfjord, and there are a lot of tourists. This was in the height of COVID. It was one of the few places where tourists could come relatively easily, given that it was only 20 kilometres from the international airport, and watch an eruption. In the bottom right here is some of my students who've just deployed a station, and I'm highlighting here there have been 12 separate eruptions since March 2021. So after 800 years of inactivity, it's become very active. And this brings it home. This plot here shows you an eruption in 2024. So this is Grindavik, the fishing village. And one thing they've done, the authorities, is build these huge levee banks of dirt about 7 metres high around sensitive regions, including the Blue Lagoon, the Svartsengi power plant, and Grindavik. And you can see this shows you where the erupted lava has travelled, and this dotted line here, or dashed line, is the levee bank, and you can see it's managed to divert some of the flow, but unfortunately this fissure, which opened up, shown in red, actually passes through or underneath the levee bank, and we've had some flow here and a little bit of flow here, so there's a bit of the fissure, and it's caused some damage in Grindavik. So now Grindavik has these walls all the way around it, and the hope is they'll protect it from future eruptions, although, as this plot shows, if the fissure opens up within the walls, then it can't really do much to help. And here's a few plots. So this is actually showing you one of these typical fissures that erupt. Very low viscosity lava, which flows out relatively rapidly, which I'll mention again shortly. And you can see the bits of lava that have flowed past the wall because the fissures are opened up beyond it, and there's the levee bank running along here. And this is a sports hall in Grindavik where a fissure has opened up, so let's put an end to the football there. And this is showing you here lava that has flowed over the road. But one thing they're quite good at in Iceland is dealing with the lava, and this plot on the right here shows you a flow of lava after March 17th, 2024. Just a week later, they managed to get rid of it and put a new bit of road in place. So they're very good at adapting to what's happening there. Okay, so now to move on to some slightly harder science. And this is the first Fagerdahlsjet intrusion and eruption, and so it intruded as a dike. You can see the seismicity shown by colours. This is time, and you can see that it's formed this dogleg in this dike about 10 kilometres long, but it's not a simple, the seismicity doesn't simply just reflect what's happening along the dike, but it reflects how the dike imposes stresses on the region around it and results in off-dike seismicity. And over on the right here we have a few slices, so X, Y, Z is running through here, AA is running through here, and you can see that we also have some very deep earthquakes which were precursory to the formation of the dike, which suggests it was melt travelling upwards. The dike itself happens in the brittle zone of the crust, and you can see it doesn't, the seismicity doesn't go all the way to the surface, probably partly due to rocks near the surface being very broken up and therefore currently support the kind of strain accumulation needed for earthquakes to happen. And this slice here shows very clearly that we have the deep earthquakes here and then seismicity coming up here, which may indicate where the initial start of the dike was. That's roughly where the eruption was, and these red dots indicate some interesting types of earthquakes, which I'll just mention on the next slide here. So what we found is that the vast majority of earthquakes ruptured on strike slip faults, and these are pre-existing structures, so as the melt comes in and forces the crust open, it's accommodated by slip on these pre-existing faults. However, just before the dike started intruding, we discovered these very interesting dip slip faults, which are at depth of about 6.2 kilometres. So this is this slice through here, and the one on the right here is this slice through here. So you can see they start deep and go shallower, and in time, these dip slip faults occur first, and then an hour later we start getting the kind of normal fractures that we see with dike propagation. So what we think we're seeing here, and on the next page you can see perhaps more clearly, I'll just zoom in, all these dip slip faults which have a fault plane that is roughly parallel to the strike of the dike. You can see that these happen before the strike slip faults and at depth. So what we think we're seeing is some sort of opening event as the melt travels up from the ductile zone into the brittle zone, where the actual dike propagation can be observed seismically. So this may be some indication that there's precursory activity we might be able to pick up prior to dike intrusion, which has some implications for hazard. Now, doing all this work in the field, earlier I said it wasn't that difficult, but there are certainly challenges. Here's one of my students at the time with one of our sensors buried in the ground with some solar panels giving it power. And we put it on a hill, which we thought was a nice distance away from where any lava might flow. However, back in 2024, in January, this is a live recording, so this was telemetred. And it's quite interesting what you see here. So these are 15-minute traces through here. And before an eruption, it's not unusual to see this period of quiescence where we don't really see any seismicity. And what it seems to indicate is that the dike is quite mature, the melt has gone near the surface and it's sort of now pooling up, and in the shallow regions, breaking the crust there doesn't really produce any earthquakes because it's so unconsolidated. But then as it finally surges through the shallowest bit of the crust and starts to erupt, you get this huge swarm of earthquakes, and the actual start of the eruption is indicated by this tremor here, which you can see this continuous low amplitude noise. But then the other thing you see is that as it goes along at this 8-minute time here, it suddenly stops. And this was a live recording, and this is what it looked like on the screen. And unfortunately, what it meant was that there was a fissure eruption very nearby, and this is the drone footage. And you can see the fissure opens up, the lava flows away from it, and unfortunately our station was just there. So it got buried under several meters of lava, and unfortunately is unrecoverable. So it's just one of the hazards of working in the area. Okay, so the second part of my talk is on ICGERE, so further north. I showed you some pictures earlier on. There's a network on the right, and here's a student and postdoc of mine who are servicing one of the stations, waiting for the data to download. And that's the station on the very northern part of the Caldera Rim. You can see the Caldera running around there. and it produces very high quality data because it's generally very quiet, not many people around, no roads, very remote. But one of the interesting things that happened here was the last eruption was in 1961, and it appears to have been largely deflating ever since. And what we see over here is a levelling line that was put in place starting off in the early 1970s. So the eruption was roughly up here, it was a fissure eruption, and the levelling line has been put every year, measurements have been taken down here. So after some sort of initial ups and down from the early 1980s, it's been very continuous as the ground surface has been subsiding, which corresponds with a deflation event. So it's probably where the melt came up is now, I guess, gradually collapsing. Any melt remaining is draining away, and we see this sort of effect. And keeping in mind this vertical axis is in meters. Now, in terms of the northern volcanic zone and how it deforms over time, what we're seeing here is some results from a GPS survey, and what you're looking at is the observed horizontal motion relative to the erosion plate. So we're standing here, we're watching the North American plate move away from us, and that's the dominant signal. So if we then, so in this case Druin 27 modelled this using several different sources. So the dominant one is plate spreading. So we know the plate's spreading at roughly 2 centimetres a year, or 18 millimetres a year, and that's the dominant signal in what we see here. But it's not the total signal. There's also quite a strong isostatic rebound resulting from the melting glaciers. That's quite significant. And then the other effect is volcanic deflation. And so all of these three sources contribute to what is observed. Now, very interestingly, in 2021, we observed a change in ASCII when we were actually there, and this was caused by a sudden, or relatively sudden onset anyway, inflation event, where what we're looking at the left here is INSAR, and it's showing you the uplift according to this. And so this is from 2023, so a few years ago, but already you can see that uplift of up to 40 centimetres has occurred. And this is the actual GPS stations shown here, and this is their vertical north and east components of motion, or displacement rather. And what you can see very clearly, I'll just point out OLAC, which is over here, so near the centre of uplift according to INSAR, and you can see that the increase in elevation is pretty significant and constant over time. This runs up to about 2024. And so this shows you very clearly that there's significant uplift, most likely due to an inflation event at depth. And this occurred in 2021. And we recorded this seismically. And so what you're looking at here is all the seismic events that we've been recording, and the red dashed line indicates when INSAR sees this sudden change from deflation to inflation, and the red line indicates the cumulative number of events we record. So very clearly these two coincide extremely well. There's no displacement in time between them, which is interesting in itself. So we've also imaged this area, and this is some tomography results, so local earthquake tomography from Jifei Han, my student. And what we're looking at is a slice at 2 kilometres depth. On the left here, this is perturbations in P wave speed, S wave speed, and VPVS. And this is a cross section through the centre here in each of these. So I guess the clearest thing is this contrast between high velocities, which are probably intrusive mafic material related to the volcanism, and there's low velocities around the outside, which are probably related to the heavy fracturing that occurs due to the fact that it sits on a rift zone. And the other thing you can see, particularly in VS, is this low velocity zone here and here, which relate to two separate magma chambers. Now you might say, well, these low velocities can also be seen here and here and here, so how do you know that's actually a magma chamber? And the kind of definitive result comes from the VPVS, because you can see that the positive perturbation of VPVS is still very strong here, but it's much weaker out here. And that's why VPVS is such a good discriminator of melt. And so these low velocities are largely due to this heavy fracturing in the crust that you can see down to roughly 3 kilometres depth. So the big takeaway point from this is we can clearly image these two low velocity zones, which are likely related to this inflation event that we saw on the previous slides. The other thing we did was try and compare this in a low velocity, shallow low velocity zone, this horizontal location, to the INSAR results. And this is showing you in the period 2015 to 2020, this is where deflation is focused in units of millimetres. And then with the inflation 21 to 2023, this is where the centre of inflation is focused. And you can see it's an order of magnitude larger, 600 millimetres, and it's really sitting above this low velocity zone. So what that probably tells us is this low velocity zone has experienced some event where the melt has come up and probably formed a sill near a stop or something and pushed up the surface. And this can be supported through ambient noise tomography. So what we've done here, what my student Joe Phone has done, is do some ambient noise tomography. This is a slice at 2 kilometres depth through the shear wave velocity model. It's a bit more diffuse than the body wave one because we're kind of dealing with surface waves now, which are longer period. But it nonetheless shows you this low velocity zone. But the other thing we did was look at radial anisotropy, and it shows you this very clear, strong radial anisotropic zone, and that corresponds with what you would expect from a cell intrusion. So that's what we think we're looking at, a shallow cell intrusion that probably is sitting above older ones, which is why the body wave tomography just images as a kind of blob. And then the surrounding region has negative radial anisotropy, probably due to the vertical cracking I alluded to earlier. Okay, the last part of my talk is on Krapler. So this is the northern part of the northern volcanic zone, and you can see these en echelon fissure swarms, each with its central volcano and Krapler here. And over the last 10 or 15 years, there's been a lot of seismic deployments around the region. We've managed to get our hands on this data, and the interest is in looking at what is below the surface. Because as you may know, Krapler is very active. Between 1975 and 1984, there was the so-called Krapler fires, which produced many eruptions over that period. I think it was 9 in total. Now there haven't been any eruptions since then, but we have the Crater Lake, which is about 300 metres across. It's extremely active as a geothermal resource. I think they currently produce about 60 megawatts from various boreholes. And there's a known magma chamber that has been drilled into, and there's a big project currently underway to try and exploit that for high temperature geothermal. So it's a very interesting place, very relevant for both hazard and for energy extraction. So this is a result of ambient noise tomography using data from those stations I showed you, undertaken by Peter Jackson, who's a co-author on this talk. And this is showing you velocity variations at 2 kilometres depth, and it clearly images the magma chamber beneath Krapler as this low velocity zone. And if we take this slice, DD, through it, you can see very clearly this low velocity blob. So that's about the depth that's consistent with where they drilled it. And this is in absolute velocity. This is velocity deviation. And you can see it shows up super clearly as this very discrete blob. The other interesting thing is this high velocity layer over the top. And what that is, or what we're looking at essentially, is we have this melt zone or magma chamber. We have this layer of gabbro over the top. Now as the ridge spreads and lava is extruded on top of it over time, this gets deeper and deeper as it gets buried. And so what we're seeing there is exactly what I've shown you here. You can see that we have this high velocity cap which deepens on either side. And the other interesting thing we see is that further to the northwest, Theisterrecker here, it shows up this low velocity blob, and recent geodetic modelling suggests there's an inflation source at about that depth. So this use of ambient noise tomography is extremely useful for understanding what's going on, and the hope is to do some higher density deployments in order to get a better understanding of particularly the geothermal setting. Okay, so we now move on to the conclusions. So since 2021, there have been 12 eruptions so far in the Reconnaissance Peninsula, and this has marked the start of a new volcanic era, given that there haven't been any prior eruptions for 800 years or so. The initial Philadelphia dike intrusion in March 2021 generated dominantly strike-slip faults on pre-existing structures, but importantly we did see precursory dip-slip events, which we think mark the transition of melt from the ductile zone in the crust to the brittle zone. Recent uplift at ICGERE appears to overlie a shallow, low velocity and high VPVS anomaly, approximately 3 kilometres below the surface. Our results from ambient noise tomography show that this is a region of positive radial anisotropy, which suggests that the low velocity zone is formed from a sequence of cell intrusions, and perhaps this recent uplift is caused by a very shallow cell intrusion above the pre-existing melt layer. And finally, ambient noise tomography of Cracklet clearly reveals a shallow magma chamber and overlying gabbro layer that gets deeper away from the ridge. Now, before I finish, I just wanted to show one slide, which is about future work in this region. So recently, several very large projects have been funded, and on the left is showing you a series of ocean bottom seismometer locations and land stations in the North Atlantic. And this is a combined German ice plume experiment. So all the pink dots, so they have 50 ocean bottom seismometers they want to deploy all around Iceland, plus 100 land-based stations. And the idea of this is to try and better image the plume at depth. And beyond that, in addition to our southern deployment I showed you earlier, we hope to deploy 28 ocean bottom seismometers to the north of Iceland in order to examine this asymmetry in the way we have mid-ocean ridges to the south and north of Iceland. So it's a very exciting time to be studying Iceland, and I hope in future years I may be able to present some of these results as well. So thank you very much for listening.
Okay, thank you very much for your attention to Professor Rawlinson's presentation. We will now have a question and answer session. The QR code will be displayed on the screen. Please take a moment to scan or take photo of the QR code and submit your question through the link provided. While you are submitting your questions, let me remind you that the question will be forwarded to Professor Rawlinson by email, and his response will be sent directly to your email addresses. Okay, thank you to everyone who joined the discussion. This concludes plenary session 7 and the plenary program of ICGERE 2026. Before we have the lunch break, there are some interesting posters at the back of the hall for you to explore. And here are the title of the posters. Here are the title of the posters, and for those who are interested, you may come to the authors directly. Thank you. And now we will break for lunch, and technical presentation 3 and the day 2 poster session will begin again at 12:30. Before we break, I will announce the room assignments. For geothermal science and engineering, please proceed to the multipurpose hall CRCS level 3. and the session will be moderated by Ms. Fauzia Mazwah. For Energy Policy and Reservoir Engineering, please proceed to Conference Hall A, CRCS Level 2, Room A210. The session will be moderated by Dr. Prasandi Abdul Aziz, and the date to poster program is listed in the Multipurpose Hall, CRCS Level 3. We kindly ask all the presenters and also the participants to be seated in their assigned rooms before the session starts. Thank you, and please enjoy your lunch. Ladies and gentlemen, this is a gentle reminder that the program will begin in 5 minutes. Please take your seat in the sign room. Thank you. Ladies and gentlemen, technical presentation 3 will now begin. For geothermal science and engineering, please stay at the multipurpose hall CRCS level 3, and the session will be moderated by Mr. Heru Berian Pratama. For energy policy and reservoir engineering, please proceed to conference hall A CRCS level 2, room A210. And the session will be moderated by Dr. Prasandi Abdul Aziz. The Day to Poster program is listed in the multipurpose hall CRCS level 3. Thank you, and we wish you have a productive session. And to Mr. Heru Berian Pratama, you may come to the stage, and the stage is yours. Thank you.
Okay, good afternoon, ladies and gentlemen, distinguished participants, and also honorable guests. And I would like to welcome you all to the session of the Geothermal Science Engineering. And thank you for coming here and stay with us until at the end of this today. And in this session, we'll have multidiscipline regarding the geothermal from the exploration, utilization, and also how to utilize by using machine learning. And without further ado, I would like to invite the first speaker, which is Mr. Putu Abel Nugraha Adian. He will talk about the fault control in non-volcanic geothermal system. Please come to the stage. You have 15 minutes presentation, and I will inform you 5-minute lapse. Okay, please start.
Check. Okay, good afternoon, everybody. First of all, I would like to say thank you to the committee for the opportunity for us to present our research. And also, I would like to say thank you for my co-author, Mr. Eric Aldo Tanuwijaya, for the collaborations, and our mentor from BIRIN, Mr. Kiadlan, for the advice and collaboration. So today, I would like to present our topic about structural geology and geothermal. Especially, the title is Role of the Walanai Fault in Controlling Structurally Hosted Non-Volcanic Geothermal Manifestation and Prospect in South Sulawesi. Okay, we know that in Indonesia there is a lot of geothermal system has been operating. Example like Patuha, Derajat, Wayang Windu, Ulu Belo, Lahendong in South Sulawesi, and in South Sumatra, Isarula. But there is all geothermal system is dominated by volcanic geothermal system. Actually, Indonesia has another geothermal system that potential that we can research deeply. We call it non-volcanic geothermal system, which is controlled by fault. So, why we choose Walanai fault? Because that I told previous, we have a potential geothermal system, the other potential geothermal system, which is non-volcanic geothermal system. So that's why we choose Walanai fault, because in South Sulawesi, there is no quarter volcanic, there is no volcanic geothermal system, but along the Walanai fault, there is a lot of geothermal manifestation that we can found. So that's why we choose Walanai fault as our research study. So theoretically, the fault has probability to slip or reactivation. It's the best fluid pathway for geothermal fluid. But the other case, there is a paradox that I will tell at the last part of presentation that why the text here is the geothermal paradox. So for this research, we want to answer one question: does present-day mechanical favorability control geothermal productivity, or is permeability governed by structural connectivity and network architecture? Okay, little brief about Walanai Fault. So Walanai Fault is divided into 4 parts. The first part is East Walanai Fault, and the second part is West Walanai Fault. So the East and West Walanai Fault is divided each into 2 parts: the North Walanai Fault, West Walanai Fault, the Southwest Walanai Fault, the Southeast Walanai Fault, and the Northwest Walanai Fault. So regionally, Walanai Fault has along around 150 kilometer, and then depression width is around 10 until 35 kilometer. It's depend on which locations. And also the segment of the slip rate is around 3.27 until 2.10 millimeter per year. And the present day stress is 99 degree east. Okay, for the next slide, this is the 4 manifestation that we use for this analysis. So we're using the 4 manifestation analysis because only this manifestation geothermal has complete data that we can use for research. Actually, there is a 14 geothermal manifestation has been published in Badan Geologi 2019 in the book titled With Potensi Panas Bumi Jilid 2. So the first one that we use is Sulili. Sulili located in Pinrang with hot spring temperature is 72 degrees Celsius, which is the hottest hot spring that we use in this analysis. With the local structure is north-south veins. The second is Masepe with hot spring thermal is 65 degrees Celsius, pH 7, and then water discharge is around 1 liter per second. With local structure is northeast to southwest Brexia. And the last one, and the third is Leja with temperature is 56 degrees Celsius, with pH 6 to 7, and water discharge 3 until 5 liter per second, with local structure north-northeast until south-southwest fractures. And the last one is Kampala, with hot spring temperature is 56 degrees Celsius, pH 6, water discharge is around 0.1 liter per second, and local structure is northeast to southwest normal fault. So this is the concept that we use for analysis. Simply, we use two calculation for this analysis, which is slip tendency that we use to know the probability of the fault or structure to slip, and the other one is dilational tendency to know probably how big probability for the fracture or structure to open. So we use the formula that proposed by Morris for slip tendency, which is formula is simple. Slip tendency equals shear stress divided by normal stress, and dilational tendency is dilational tendency, we use equation proposed by Ferrell, which is the equation slip dilational tendency equal to maximum stress minus normal stress divided by maximum stress minus minimum stress. Here are the results. So based on the previous slide, after we calculate all the data, we divided the result into 3 tier. The first tier is formed by high slip tendency and high dilational. The second tier is formed by intermediate slip tendency and intermediate dilational tendentional. And then the last tier is formed by low slip tendency and low dilational tendency. If we see on the bar, on the left side is slip tendency result calculation, and the right side is dilational tendency calculation. From the 3 tier, we know that Wallani fault is more reactive and has highest probability to slip or dilational, and then Leja and Sulili has the lowest value of probability to slip and dilational. But if we look at the first slide before that we talk about thermal manifestation, we remember that Leja and Sulili has the highest temperature of thermal spring. So this is give us the paradox. This is quantifying our paradox. So thermal and Sulili fracture, local fracture, cannot be explained by present day stress after we calculate the slip tendency and dilational tendency. We also know there is an uncertainty in every research. So we're doing a Monte Carlo testing using 20,000 realization and using an uncertainty in strike dip plus minus 10 degree, and then maximum stress plus minus 15 degree, and then intermediate stress for 0.3 until 0.7. But after we doing the analysis for the uncertainty using Monte Carlo methods, the result showing us the same result. All part of Wallani faults showing that high probability for slip, and Leja and Sulili still showing us the lowest probability to slip. The value is only 0.9% until 2.2%, and for all part of Wallani fault all is higher than 80%. Okay, for the next slide, we know that slip can be reactive if we have a pore pressure data. So we try to look at the closest well data that has been applied in South Sulawesi. Actually, this well is very far from for thermal manifestation, but we try to input the pore pressure data because we know normal stress and shear stress has an impact from pore pressure data. So before we calculate the effective normal stress here and normalized pore pressure, we doing normalized pore pressure because the stress that we calculate before, we using the normalized value. So we normalize the pore pressure, and then we correlate pore pressure normalized with the stress normalized. And after that, we also calculate the effective slip tendency, which the equation is effective slip tendency, shear stress divided by normal stress minus by pore pressure normalized. So the value is showing us the same result. Leja and Sulili still under slip coefficient, which is 0.6, and all part of Wallani fault is highest probability to slip, still has high probability to slip, and Masepe Kapala, the position is in the middle, which is intermediate probability to slip. So for the last is the conclusion. So there is the first quantitative slip tendency and the dilational tendency analysis that we apply in Wallani fault system structural element under a normalized present day. The second is sleep tendency. It doesn't mean or same with hydraulic productivity. As we can see on the tier 3, there is Leja and Sulili has the highest temperature of thermal spring, has water discharge also in high value. But after we calculate the fracture using the present day or stress maximum, the result is not mechanical favorability. And the third is three-tier hierarchy is robust. After we doing a Monte Carlo analysis, the result is still same. And the last one is implication for exploration. For the exploration or future research, maybe we must consider the other side, like paleo stress analysis, fracture connectivity, or structure architecture itself. Okay, for the last, I would like to say thank you for the previous study, especially tectonic evolution and geothermal manifestation analysis in South Sulawesi, because we use it as a scientific baseline for this research. And I would like to say thank you for my presentation. Maybe that's all my presentation. I would like to be happy to discuss and answer any question. Thank you.
Thank you very much for your presentations. And I would like to invite the floor in this room. If you have any question, please raise your hand, state your affiliation and name, and please ask the presenter. Okay, please.
Okay, let me introduce myself. I'm Faizal from Biological Engineering. I just want to ask about in the previous PowerPoint, we know that several manifestation, right? We have the thermal manifestation. I just want to know in your data in the thermal manifestation, this geothermal system is what type or non-volcanic, but we don't know. And in the PowerPoint is does not conclude about this is high temperature or low temperature or medium. I just want to know what type of this geothermal system in in the South Sulawesi.
Okay.
And also these are this structural complex involved in South Sulawesi is contribute in the exploration or no. And yeah, this is from me. Thank you.
Okay, thank you. Nice question. Can we show the presentation slide? Okay. So for the first question is what kind of type of geothermal from this all manifestation, right? Okay, so from the data that I read in Badan Geologi book, actually this was archived by Badan Geologi. So Sulili, Masih, Peleja, and Kampala is the deep geothermal system. So the heat source is come from radiogenic or granite intrusive. And then the second, you can read it on Badan Geologi. The book's title is Panas Bumi Jilid 2, Potensi Panas Bumi Jilid 2. You can find it on internet. And then the complexity of structural in South Sulawesi, I can say yes, because actually here in South Sulawesi, there is another well that we can use here. That actually we can use to calculate pore pressure data, but the data is dry. If you know drilling in Rekang, there is well called Tondon 1 and Loka 1. There is oil and gas well. Has been drilled in South Sulawesi, but the well is dry and failed to targeted the reservoir because the complexity of structural, the drill pipe is stuck, so they closed the well until now, and there is no exploration or drilling in South Sulawesi again. Thank you.
Is there anyone else? Okay, I think it's enough because our time is limited. And please, thank you very much, and please give the presenter applause. Please join forward. Okay, thank you very much. And we would like to proceed to the second presenter. And on behalf of the committee, the presenter is online, so we will see the presentations on the Zoom. Okay, please committee. Okay, and Mr. Helmi, you have 15 minutes presentation, and I will inform you 15 minutes left. Please, the time is yours.
Okay. Actually, can you see my screen? Okay. I just want to confirmation. Okay. Can you hear my voice? Okay. Good afternoon, everyone. It's my pleasure to present our research with the title Diagnostic Method for Assessing AI Value Creation Readiness in the Oil and Gas Industry. My name is Helvin Rajaya. I'm from Interdisciplinary School of Management and Technology in ITS and also from Pertamina. I would like to thank you for the committee for the opportunity, and I'm sorry I cannot attend in person because there is a company policy regarding mobility risk because of the public demonstration in here. I would like to thank to Pertamina and also my promoter and co-promoter Bu Elia and Pak Hazik. The presentation consists of 4 parts. First, I will briefly explain about the background and the research questions. The second, I will explain the proposed the diagnostic method. And the third is I will present the results of my oil and gas demonstration. And also the last one is I will summarize the main findings and implications. Let me start with the broader context here. The oil and gas industry is facing increasingly complex challenges. Companies are under pressure to improve production and then operational, maintain competitiveness, manage hazards, and also support the energy transition. In this context, AI, or artificial intelligence, is no longer about the technological trend, but it is now as a strategic necessity. AI is being applied across the value chain of the oil and gas, from upstream to downstream, exploration, production. If you can see here, this leads us to what we call the 50% paradox. As shown on the slide, technical progress maybe can increase rapidly during the development phase. You can build the model AI, develop, test it, deploy, and also operate it. However, but the realization of the business value from the AI may remain significantly lower. In other words, there are often substantial gap between the technical and also the realized business value. This is very important because organization may report that an AI use case has been successfully deployed, while the expected financial or operational impact has not yet materialized. Therefore, the key question is not simply, is the AI solution working, but rather, is the organization ready to turn the AI solution into the measurable business value? To demonstrate the method, we use a case involving 8 operational AI use cases that has been developed by the internal Pertamina within a digital factory program. These AI use cases cover different parts of energy value chain. For example, AI-based vessel performance monitoring, we call vessel. Explo support AI-based exploration well prediction. BIRD focuses on AI-based vessel arrival prediction. Guesthouse predict AI-based residential guest customers. Well, Geo supports AI-based geothermal production zone prediction. Port monitors AI-based port performance. Optim focuses on AI-based crude oil procurement optimization. And Gastrans focuses on AI-based gas transmission pipeline monitoring. Their potential value also varies considerably, ranging from less than $10 million to more than $20 million. Based on this problem, we developed 2 research questions. The first question is, what socio-technical barriers hinder the transition of AI use cases from technical implementation to realized business value during the operationalization phase. And the second question is how can the value creation readiness of operational AI use cases be systemically assessed and monitored? This slide presents the proposed diagnostic method. The process consists of several sequential steps. First, we identified the AI use case being assessed. Second, we assess it against a taxonomy of AI failure factors. Third, we identify the remaining critical gaps. These gaps are translated into an overall AI value creation readiness assessment using three confidence levels: high, medium, and low. But the assessment does not stop at assigning of confidence level. The next step is to derive actionable leading indicators. The indicator tell us whether the identified gaps are actually being resolved or not. Finally, we monitor the progress of gap resolution and connect it with lagging indicators, which measure the actual realization of business value. So the basic logic is identify the gaps, assess the readiness, defining leading indicators, monitor the gaps, and eventually measure realized value. To identify these gaps systematically, we developed a taxonomy consists of 8 failure factors. If you see the left one, there are mainly technical factors. The first is infrastructure, referring to the availability and adequacy of the technical infrastructure like cloud, maybe on-prem server, something like that. The second is data governance, covering the data quality, accessibility, integration, governance. The third is a model, which refers to a capability of the AI model algorithm to produce reliable prediction or recommendation. And the fourth is use case, which concerns the scope, the complexity, and dependency of the AI use case or the project itself. And the right side, there are 4 socio factors regarding about the organization concern, about the policy, resources, coordination, change management, about the addresses organization readiness, user adoption focuses on acceptance, trust, effective use, and the last one is the business concern alignment with the business objective and measurable outcomes. After identifying the gaps, we determine the confidence level. If only one gap remains, the use case is classified as high confidence. If there are 2 or 3 gaps, it is classified as medium confidence. And if there are more than 3 gaps, it is classified as low confidence, indicating systematic barrier before value can be realized. However, confidence level is not intended to be a final judgment. It is a diagnostic signal. This is where leading and lagging indicators become important. Leading indicator provide early signal that the use case is moving toward the value realization. For example, completing data integration or establishing a business KPI. On the other hand, lagging indicator measure the actual business outcome. For example, reducing turnaround time, increasing utilization, or avoiding a dry well from the exploration. Therefore, leading indicator tell us whether we are on the right path, while lagging indicator tell us whether we have actually achieved the value. For the case demonstration, we used 2 assessment points. The first was the AI value creation KPI target setting workshop conducted from 6 to 13 March 2026. At this stage, a total of 30 digital initiatives were reviewed, and then AI use cases were assessed in terms of their value creation readiness. The second assessment was an AI value creation steering committee review conducted on 1 July 2026. The second assessment focused on implementation progress and resolve socio-technical barriers, and also the business value realization. This 2-point assessment is important because readiness is not static. It can improve when barriers are resolved, but it can also decrease when new barriers emerge. Okay, this is the result. Let me now move for the result. During the March, we can see the several use cases were classified as a medium confidence. For vessel, the major issue was logistic data readiness. So the problem is the data, the leading indicator, the integration, and the KPI. For the port, a similar data like integration also the issue. And then in the Optim, we can see that the key issue was the model enhancement, the algorithm. And the for Expro in the upstream side, model refinement was still required, while drilling activity has been postponed to 2027. An interesting case is BIRD. If you can see, it's classified as low confidence here because the gaps were very complex because there is problem in the governance, problem in stakeholder, change management, data, and user acceptance. In contrast, if you can see gas house, gas trends, well geo, there is no problem, there is no issue. Where assess is high confidence because it's only the business barriers. In the steering committee review, if you can see, several changes occurred. For the vessel, the logistic and the integration were still ongoing. The port, data readiness, product owner onboarding remain important. For the Optim, model enhancement and product owner transition will still wait. Okay, sorry.
5
Okay,
minutes.
Explore, yeah, Explore remain medium confidence because drilling was postponed to 2027 and model refine was still required. The most critical case remained BERT, which was still classified as low confidence. The key issue was low model accuracy about the algorithm. This is a very important finding because a technical functioning AI solution does not automatically translate into business value if the downstream business process is not ready to use its output. If you can see the gas trends, the confidence level decreasing from the high to medium. The assessment identified as a new issue because the organization adoption readiness and in addition to contract execution requirement. This demonstrates that AI readiness is very dynamic. A use case can become less ready not because the technology, but because of the new organizational barrier emerge. The slide summarizes the readiness level after the steering committee review. We can see three high confidence use cases: gas house, well geo with gas trend moving to the medium. Several use cases remain at the medium confidence, including the vessel, port, Optim, and Explo, and but remain low confidence. The important point here is that the confidence level should not be interpreted simply as a score of ranking. It provides management with a way to determine where intervention is most needed. For example, a low confidence use case may require organization restructuring, user engagement, model improvement, and the business alignment before significant value can be expected. Meanwhile, a high confidence use case may require mainly monitoring and execution. Therefore, the diagnostic method can help organization prioritize their management attention and resources. Let me conclude with four key findings. First, AI value realization is driven more by socio-technical factors than by technical factors alone. The technology may already work, but value can still be blocked by governance, organization change management, user adoption, or business alignment. Second, the proposed diagnostic method assess AI value readiness using three complementary elements: confidence levels, failure factors, and value indicators. Third, AI value readiness is very dynamic. It can improve as a barrier resolved, but it can also decline when new barriers emerge during the operationalization. And the fourth, the method provides a practical bridge between technical implementation and business value realization by translating identified gaps into actionable leading indicators and linking them to lagging business outcomes. However, we recognize that further validation is needed across different organizations to test the reliability and predictive capability of the method. This is the references that I used. And so the main message of this research is simple. Deploying AI is not the finish line. The real challenge is converting AI deployment into measurable and sustainable business value. And to achieve that, organizations need to continuously diagnose not only whether the technology is ready, but also whether the data, organization, people, user, business are ready to capture the value. Thank you very much for your attention. I will be happy to take your questions. Thank you very much.
Okay, thank you very much, Mr. Helmi, for your great presentation, also great idea. And I would, due to our limitation of time, I would like to invite only one question. Okay, since there is no question on the floor, I would like to ask you regarding how can you implement AI readiness score quantitatively into the operational and also financials, because it's very important for us to make that AI help in kind of the projects.
Yeah. Okay. Thank you for the question. Everybody always said about the AI, but everybody always think about the AI is only for development the model. but it is very wrong. If you go to the organization or the company, it's very totally different because we invest the technology. So there is capital aspect or the capex. So how to implement the readiness score? We have to chip in our process, not only in development, but also we mitigate the process of diagnostic in the operationalization. We're tracking all the process, like the 8 use case that already I mentioned before, like in the port, vessel, something like that. We track, we discuss with the user what is the problem, and we check all the diagnostic the process. Because without the diagnostic process, we don't know what problem that the AI. If you see the report from the MIT, there are 95% the AI is failure. So only 5% getting the ROI or the benefit from the revenue to the company. So how to implement it? Yeah, that's why I use the diagnostic. This is implement in my company also, and we just tested in the two event from the workshop and also the steerco. This is the board meeting, something like that. Maybe that's all for my answer. Thank you very much for the questions.
Okay, thank you very much. I think it's up. And to close the second presentation, I would like to give you a certificate of appreciations. And committee, please show the picture of Mr. Helmi. Could you show the first page of your presentations?
Oh, okay, sorry. Okay.
Okay, please take a picture and smile. Okay, thank you very much. Please give applause for Mr. Helmi.
Thank you very much.
And to continue to the third presentation, I would like to invite Mr. Bagus to come forward and share their idea regarding his topic. Okay, Mr. Bagus will talk about the uncertainty assessment. So in petrophysical logs. Without further ado, I would like to give the podium to you. 15 minutes presentations. And I would like to inform you 5 minutes left.
Tes. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. First of all, I would like to thanks to the committee, also the session chair, to give me an opportunity to present our research here. And also, I want to thanks to my commenter, Naswan Taufikur Rahman, and also Raffi Pandu Widyadana for making this happen. My name is Bagus Alfa Ramadan, and with today's agenda, I will present our presentation with the title is Uncertainty Assessment of Petrophysical Log Interpretation and its Impact on Reservoir Engineering Decision Making, a case study from Mature Reservoir Central Sumatra Basin. So we move to the introduction slide. Here's the study area located in Central Sumatra Basin, and we focus only on 2 wells. The first one is C6-411, and the other one is D6-303. This reservoir interval is a heavy oil reservoir that has experienced long-term thermal production and also steam flooding. With this case, with this study, it leads to our main case, which is uncertainty that we have. Uncertainty, first we have to understand whether the uncertainty from the petrophysics calculation, open hole data, case hole data, or whether the real condition of the reservoir dynamic. So we go to the methodology. We have data availability, where in this 2 well, we have open hole log, well surveillance log from 2015, 2020, and also 2025. With the workflow, we want to search the base of uncertainty. We divide it into 4 uncertainty. There's measurement, environmental, petrophysics, and reservoir condition. With this data, we compare it also, we do calibration with open hole log data, cache hole data, and core data to know the low, base, high of the value of this petrophysical evaluation. Next, with the low, base, high value, we do the Monte Carlo simulation to know the parameter ranking that affect the properties of the reservoir. We go to the uncertainty result. The first one is measurement uncertainty. From the measurement, we know there's a potential uncertainty that may affect the reservoir properties that we calculate using petrophysics. And next, for the environmental uncertainty, we know that the borehole condition, the well integrity, and also the formation condition, it's gonna impact to the logging data, especially the triple combo data that we use here. And from this, it's also affect that cache hole data or well surveillance data, because the cement's integrity, and it's gonna impact PNC, CO carbon log, and also the neutron log. And here's the petrophysical uncertainty. Here from the well C6411 and also D6303, there is so many uncertainty in petrophysical, but mostly based on the calculation or the model that we choose. We have to choose the suitable model to our reservoir data, and also we have to compare it with other models. And from the reservoir condition uncertainty, we have this initial data, which is the data from after the drilling. And also we have surveillance data 2015, 2020, and also 2025. This data may reflect changes in the reservoir, and also the well surveillance log. It may reflect on fluid redistribution or distribution. But we have to know that the surveillance data also have uncertainty, like the 2015, it not suit the 2020 and also the 2025 on well C6411. Like there is effect called, some people called it resaturation, but we know there's an uncertainty that going on there, not the actual resaturation. For the result on comparative petrophysical evaluation, from this we want to know the geological characteristic, and from this characteristic we choose the model, which is the stable model and also comparative model. From this, we can know the petrophysical uncertainty, and we divide it into 3 value, which is low, base, and high. Low and high is selected by the model, which give it the result or the value from this model. For the base case, we use the core by core data. From this, we have to calibrate the data and all the important data like PyT, SO, and also neutron porosity. From this, we have the low, base, high result. We choose only three main data: net pay, oil saturation, and effective porosity, because we want to simulate it on STOIP calculation with Monte Carlo simulation. Okay, with the sensitivity analysis from Monte Carlo simulation, we divide it into 4 percentile. There is P90, P50, P29, and P10. P29, the realistic data, we choose based on the actual data in the field, like the core data. And the STOIP in initial range from 800,000 SDB to 1.5 million SDB. For current condition, 300,000 to 500,000 1000 STB. With the result from the sensitivity, SO, oil saturation, is the most impact data, followed by pi-e, and the last is net pay. Now, the last slide is conclusion. Petrophysical uncertainty is multi-source originating from measurement limitation, environmental, borehole condition, interpretation, model selection, and changes in reservoir condition. Integrating this data provides a more constrained reservoir interpretation, enabling calibration and cross-validation of petrophysical properties under both initial and current condition. Dynamic surveillance response must be distinguished from actual changes in reservoir value, as variation in saturation oil, steam saturation, thermal porosity, and temperature may reflect near wellbore fluid redistribution, steam migration, or thermal evolution. Oil saturation is the most dominant contributor to STOIIP uncertainty, followed by pi and net pay. The integrated uncertainty-aware workflow provides more reliable basis for STOIIP estimation, remaining hydrocarbon evaluation, and reservoir engineering decision-making in major steam flood reservoir. That's it from me. I would like welcome to anyone who want to ask the question. Thank you.
Thank you very much, Mr. Bagus, for your presentations and interesting idea regarding the how do you develop the uncertainty analysis. And I would like to invite questions. If you have any question, please raise your hands, state your affiliation name before you ask your questions. Okay, please help the committee.
Okay, my name is Putra Banugrardian. Before I ask my question, the presentation is good, nice for the uncertainty analysis. So I just want to know, for the uncertainty analysis, do you make a design for the uncertainty? So what and how many realization that you doing? Do you make a design for the uncertainty, like like if we doing the Monte Carlo analysis and Monte Carlo uncertainty, there is a full factorial design that we can design the design of uncertainty, or just a random uncertainty, and how realization do you use? And the second question is, the sensitivity do you test? What kind of method, so that we know the water saturation is the most sensitive for your uncertainty test? Thank you.
Okay, thank you for the question. I would like to answer this question. For the model, we do not make it because the uncertainty data that we use, we calculated from the STOIIP calculation only for the Monte Carlo simulation, but the other, like the surveillance data and also the calibration, we do the the differentiation from the data. Like, can I show the slide? Like the green one is SOCO, or PNC CO carbon log. There's uncertainty. Where's the 2015 data? There's very low saturation of the oil. But in 2020 and also the 2025, it seems like redistribution because the value goes higher. So we do this for the well surveillance uncertainty analysis. Is that answer your question? Okay, thank you.
Okay, thank you. If there anyone else, yes, we still have plenty of time. So since there are no questions, I would like to ask you something like, it's become common to use the Monte Carlo and also sensitivity analysis to evaluate the parameter. So in my question, how can you reduce that uncertainty based on the data distribution, because it's very important to have that kind of distribution that makes sure it represents the actual conditions, because it will be impactful to the for example in your case reserve estimation and also decision when we do the planning of the next drilling.
So I would like to repeat the question. So the question is how I know the saturation of the.
How can you reduce the uncertainty in each parameter?
So how to reduce the uncertainty for each parameter? First of all, I would like to discuss it with open hole data. By this open hole data, there's so many uncertainty, but we have to do many things from this data, because we want to know the well integrity data, the borehole condition data, and also the formation data. For if we know there is a bad hole or something, we can do the recalculation or the normalization to this data. So it's going to show the right value for each open hole of data. And for the petrophysical calculation, like the volume of shell, the porosity, and also the saturation and permeability, of course. First of all, we want to do normalization to reduce the uncertainty for the volume of shell. Next, for the porosity analysis, we want to choose the correct model. And for the saturation water, we want to choose the right water bearing interval, the right volume of shell, the right shell porosity. So the data is show the right value of saturation, water saturation. From that calculation, we have to calibrate it with the core data. So it's reduce the uncertainty. And then we also have the base data, like well surveillance. We have to also calibrate it with the well surveillance data, because there's no make sense if the water saturation or oil saturation, the initial is lower than the well surveillance data. If there's a mistake because of that, we have to do recalculation so that the data shows the right value. And also for the well surveillance data, we have to calibrate it with the core data. So it's give the right value and the reduce uncertainty. I think that's it.
Okay, thank you very much. I think that's the end of the third presenter, and please join and center of the stage. Okay, thank you very much. Following to the next presenter, Ferdian, I would like to invite him to the center of the stage, and he will talk about the study of limestone deposit in Tulehu geothermal fields. You have 15 minutes presentation, and I would like to inform 5 minutes left on your time. So the podium is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you for the opportunity to share my research. My research is study of limestone deposit in the Tulehu geothermal system based on geological data, hydrothermal alteration, and subsurface drilling data. My name is Ferdian Hiradi from Geothermal Engineering Master Program. Okay, next. The background is Tulehu geothermal field is located in Ambon Island, administratively in Salahutu District, Central Maluku Regency, and Maluku Province. Tulehu geothermal field developed by PLN, with the target capacity is 10 megawatt, and commercial that is the 2031. Source power plant in Maluku is dominant from the diesel fuel, and the geothermal development had a big opportunity to reach the target Indonesian net zero emission for 2050. Next slide. Next. Nggak bisa. Oh, bisa. This the exploration planned doing in Toledo. The first study is in 2007 and 2010, Geoscience study and thermal gradient hole. Estimately, the temperature reservoir is 263 derajat Celsius, and the well is a shallow, in the deep is 150 meter. The second exploration is Toledo 01. The depth is 933 and the temperature is 150. It's low to medium enthalpy. This field is water dominated. The next project is the direct drilling campaigns with 4 well. Is Telugu D1, Telugu B1, Telugu C1, and Telugu B2. My research question is the limestone formation found in the Toledo reservoir is strictly in the surface or the same or different? And the second is, what is the current equilibrium temperature in the reservoir? Research purpose is to study, investigate the influence of limestone formation in the surface and the subsurface, to determine the evaluation of subsurface temperature in Toledo thermal system by comparing past formation temperature and the current condition. Next. This is my method. We use data from drilling logs and petrography, XRD, geological structure, PT logging from drilling, and full chemistry from reservoir. This is the discussion, lithology. The lithology in the Toledo consists of 11 formation, dominant from pyroclastic in the tertiary, and the limestone is quarterly. The blue one is limestone. Next, this the well lithology. There is limestone in blue. The next is tuff rhyolite, the green one, and tuff dacite, the pink. This the deep. Okay, the limestone is the coral limestone because they are deposit in the shallow marine. So after the volcanic deposition of Mount Eriwakang, the tuff one, there is a stop from the volcanic activity and the gamping is deposit. This is the limestone in Toledo. This limestone unit generally consists of reef or limestone composed of coral, plenty head, and the branching. Classification appear in several locations. Limestone found Hue, Mount Eriwakang, Hatuasa, and Sariutu traverse. Locally, gray muddy limestone. Okay, this reef deposition. The reef is the organism life, so they're very sensitive when they are contact with the volcanic activity. So they cannot live together in the volcanic activity eruption. The next is the thermal alteration. This is the mineralogy. To mention the temperature significant. This thermal alteration happen in the drilling well is replacement and direct deposition. Replacement is the host rock mineralogy is replaced with new secondary mineral based on the condition is stability. So the new mineral is occurring in the position of the primary mineral. The next is direct deposition. Direct deposition is only product of encountering vein with the rock's body. So the mineral is inside the gap, the vein. This the stage of hydrothermal alteration in Toledo. The stage 1 is high temperature mineral occurring from antinolite, epidot, and quartz. The next is mineral anhydrite. The stage 3 is the mineral calcite and silica is replace the mineral, the precious mineral. Okay, the well alteration zone. There is algolic from until 180 degrees Celsius, subprophyllitic and prophyllitic more than 240 degrees Celsius. Okay, next. The subsurface temperature. From the brand from the well, we calculate the composition of the reservoir fluid based on geoindicator CLMG, CAMG, then CLSO4 from Nicholson. We compare to the seawater, this occurrence of the source of the fluid is from seawater or not. The seawater is have a high NA. NA is 10,560, but in the Tolehu, the concentration of NA is around 2,000 until 5,000 maximally. So there is, we can predict no seawater occurrence to the reservoir. The next is this air motorics has a source of inflow in the reservoir. The aromatorics normally have a concentration of Mg is 0.01 until 0.1 mg per kilogram. And in the well from TLU-D1 and TLU-B1, the concentration is 20 until 200. From 8 to 22. So there is a interaction from the meteoric water to the geothermal fluid in the reservoir of Tulehu. Next, this we are use geothermometer from the mineral. This line is temperature from the drilling, and the red one is the temperature from the mineral deposition. The geothermometer from geothermometer. There's a difference. From this data we can predict there is a cooling happen in the reservoir of Tulehu reservoir, because when the mineral deposition occur, there is a high temperature, but when we are do the drilling exploration, the temperature is lower than the previous mineral deposition.
5 minutes left.
Okay. This is the evolution geothermal system from Miocene to Pliocene. The final phase of tectonic activity on the Ambon Island is involved compression in cause of formation of Mount Salahutu complex, conditioning of the overall formation of Ambon Island. Tectonic activity also caused the Ambon to undergo gradual uplift and ongoing volcanic activity from Mount Eriwakang, the deposit of andesite, and after that the tuff rhyolite. The next activity is Pleistocene, is uplifting of Ambon Island, fully emerged from Mount Eriwakang and Mount Hue, survive organically submerged until the reef limestone occurrence. Geothermal system, the head source may be a secondary intrusion under Mount Eriwakang, because the activity volcanic from the rhyolitic tuff is postponed until the position of reef limestone, and after that there is a new second intrusion to make the alteration in the reservoir of Tulehu. There is a high temperature thermal system characterization. The surface manifestation, there is a fumarole in the surface. The high temperature thermal system, the mineral characterization is epidot, quartz, and chlorite and illite. The low temperature is actinolite and epidot replaced by mineral calcite. This is the conclusion. First is hydrothermal alteration into hydrothermal field are formed by natural pH fluid nearly surface, selected dominated as argillic zone, as clay cap with chloride and epidot characterization. The formation alteration mineral consists of two alteration style, replacement and direct depositional. For hydrothermal mineralization paragenesis, so that at least three stages. Initial state characterization is high temperature mineral, the occurrence of actinolite, epidot, and quartz. The second stage is anhydrite and calcite overprint with high temperature mineral. The last is calcite and silica when the cooling happen. The next, okay, Telauge geothermal system initially has a high temperature geothermal system around 280. This mid to high temperature, but after we are doing the exploration project and drilling, the temperature is estimate around 210 derajat Celsius. Thank you for that my presentation. There is a question.
Okay, thank you very much for your presentation, and I would like to invite several questions on the floor. Okay, seems there is no questions. Okay. I'm just curious. Your title is talk about the limestone deposits, and could you elaborate how is these deposits influence in the reservoir condition and also the fluids? Because we believe that the Toledo geothermal field has a scaling that has severe. So could you elaborate in this case of your study the influence of the deposit itself?
Yes, the calcite deposit is happen in the bore from reservoir. So when we see calcite, the calcite is the same characterization with the limestone in the surface. So in this study, I'm to characterize the surface limestone and subsurface limestone. There's a difference. The subsurface is a secondary mineral. Is inside the fan, so there is not there is a cooling happen in the reservoir, but in the calcite in the surface is from limestone with rich reef environmental deposition. There's a primary deposition and can be act as a primary permeability because they are away from the inflow of water in the surface. So it's the different limestone.
Do you find any evidence regarding the limestone deposit on your wellbore rock in the cutting analysis?
The risk, but it's not too much. Yes, not all. Mostly we found in the TLU day one, the calcite.
What is the depth?
Depth around 107, 1,700.
Okay, thank you. Is there any questions from the floor? It seems there is no more question and our time is up. Please give the presenter applause, and I would like to give the certificate of the participation.
Thank you.
Okay, moving on to the next presenter, which is next presenter, Mr. Teddy Ardiansa will talk about the isolating local thermal perturbation in exchange geothermal. Please come forward. And I think this is a good topic because it will be a lesson learned from the Utah Forge geothermal field in the USA. We have 15-minute presentations. I would now like to inform you of 5-minute labs. Please use your times wisely.
Okay, good afternoon, everyone. My name is Teddy Ardiasha from Department of Geological Engineering, General Sudirman University. Today I will be presenting our research with title Isolating Local Thermal Perturbation in Enhanced Geothermal System, focusing on a physics-constrained residual learning framework at Utah Fort site, especially at single well analysis, well 5832. So we will begin with the core of the Enhanced Geothermal System Characterization Challenge. Our goal is how to accurate thermal characterization in low permeability crystalline rocks. But the problem was absolute temperature prediction obscure localized thermal anomalies. The cause is visible at the two-dimensional reservoir conceptual model. The granitoid basement is overwhelmingly dominated by regional convective heat flow. So as you can see, at the one-dimensional thermal profile, the massive baseline hides our target zone, and then consequently, the machine learning struggles with blind extrapolation outside training domains because it merely memorizes the regional trend rather than the localized anomaly. So to overcome this limitation, we must shift the predictive paradigm. Instead of predicting absolute temperature, our objective is to isolate the thermal residual, or delta T. As shown in the equation and the track on the screen, we perform a base depth geological decomposition. In track 1, thermal structure, we mathematically subtract the green conductive baseline from the raw temperature. The result is the track 2, the local perturbation, or delta T. The isolated local thermal perturbation, when you compare this to the waterline response at the track T, the advantage is clear. When we remove regional conductive gradient to isolate, we get true reservoir target. Okay. This brings us to critical geological translation. Disentangling mechanical from hydraulic fracture. In the mechanistic process model shown here, mechanical proxies like the fracture density orange detect all structure breaks, include the mineralized or silted fracture. It induces non-informative variance acting as false positive. So in contrast, the thermal indicator in purple and our target on the red is the delta T. It is accurately isolate the true effective anomalies. And the key finding is the fundamental, that is the mechanically fractured intervals do not equal with thermally responsive interval. Okay, to automate the reconstruction of this delta T, we developed a pin inspired architecture. The network takes or standardized input and predict the residual. However, to prevent it from fitting to mechanical noise, we implement the physics informed loss function. So in the box, this custom constraint penalize unstable non-monotonic thermal oscillation along the depth gradient. By applying this derivative-based penalty, we force the network to produce a smooth, stable, and physically realistic thermal gradient. So we evaluated this model strictly on blind extrapolation in deep unobserved intervals. And the geological filter ablation in analysis on the left reveals actual insight. When we remove the mechanical proxy, predictive performance actually improved, yielding the highest R square at 0.554 with our non-linear pin. And furthermore, the proxy to residual functional coupling on the right demonstrate that the relationship between the thermal indicator and true thermal deviation is highly nonlinear, a complexity that our pin effectively captured. So as you can see, the impact of the framework in the error density distribution from the test zone, the gray area represent the baseline residual. By isolating local perturbation and applying our pin, the red error distribution is significantly tighter and closer to zero. This proves that our approach reduces spatial extrapolation bias compared to pure conductive baseline, providing a robust and data-driven screening tool for preliminary reservoir assessment. Which by not, substantial thermal variability is governed by unresolved geological controls beyond standard logging. There is a complete synthesis of our physical construct residual learning framework from the conceptual, macro model, and wireline inputs on the left, moving through to the field decomposition, and finally into the PN methodology. The key finding on the right confirm the thermal flow indicator from regional conductive dominance. So to summarize our key takeaway, first, signal decomposition. By targeting thermal residual or delta T, it can create a rigorous reference frames. Second, proxy disconnect. There is a proxy disconnect that mechanical fractures do not systemically align with active thermal transport. And third, nonlinear reconstruction. So as the PIN effectively identifies nonlinear thermal behavior, outperforming linear approximation. And ultimately, for enhanced geothermal system application, extend residual learning toward geology-guided reservoir screening prior to expensive stimulation. And here for key reference, and I want to thank the Utah Fort for the project and data publication. And I want to thank you all for your attention. That's all for me.
Okay, thank you very much for your interesting presentation, and I would like to inform, we would like to open the question and answer sessions. And if you have any question, do not hesitate, raise your hands, state your affiliation and also your name before you asking a question. Okay, thank you. Committee, please help and give the microphone to the someone who asks.
Okay, thank you. Nice presentation. My name is Putu Abel Rarian. I'm from ITB. I'd like to ask you about the fracture mechanical. Did you have the image log data that you used to see the fracture or to calculate the fracture? Because at the conclusion slide that you told the fracture is not mechanical for the heat transport, right? I just want to know. Maybe that's
Okay, for the virtual image about fracture or FMI, we do not input that to our pin. We just input the mechanical loads like log density and more about that. So that's all what we use.
Okay. Is there any questions? Okay. You implemented the method, the framework to the EGS. When this method you applied, what is the main challenge and how you overcome to solve the problem? Because I believe in your presentation the accuracy is quite relatively low. For example, the R square is only 1.5. Oh yes.
Sorry, can you repeat?
Okay. You built a machine learning or just a framework to analyze the thermal perturbations in your study. And what is the main challenge when you applied this framework? And how you overcome that?
Main change.
The main challenge. Just give us your experience when you do your study.
Okay. This research is more complex at the process what we built our pin model, because there's a lot code what we built, and we need to input the physical constraints to the model, And of course, there are so many errors and so many trying at this research. And after all what we do to finish this research, we found that something in thermal behavior is not all linear. There's something non-linear thermal behavior, and we found it by the use PIN and AI and machine learning, like that.
Okay, thank you very much. Is there anyone else? Okay, if not, I would like to close these sessions and thank you very much. Please come to the center of the podium. I would like to give your certificate of appreciation. Okay, thank you very much, ladies and gentlemen, and participants, and also the speakers from these sessions. That's the end of our session of the Geothermal Science and Engineering, and thank you very much for your active participation in these rooms. And before continue to the next schedule of this ICGERE program, I would like to give to the Master of Ceremony. Thank you very much once again.
Thank you very much to all of the speakers for such an insightful presentation, and also to the moderator. Thank you so much. We will now continue to technical presentation 4. For mining and engineering, please stay to the multi-purpose hall CRCS level 3. And the session will be moderated by Insinyur Ari Naftali Hawuhade, PhD. And for energy transition and security, please proceed to Conference Hall A, CRCS level 2, room A210. The session will be moderated by Dr. Prasandi Abdul Aziz. And the Day 2 poster program continues in the designated area of the multipurpose hall CRCS level 3. We wish all presenters a successful final technical session, and to Insinyur Ari Naftali Hawuhade, you may come to the stage, and the stage is yours.
Good afternoon, ladies and gentlemen. Now we will continue to the next session about mining engineering, and I will remind you again for the all presenters, there will be allocated time, maximum 15 minutes. I will remind you after 10 minutes. Okay, maybe I will start for the first presenters. Pardon me. Muhammad Raihan Aziz. Raihan will talk about engineering intervention for pit lake overflow.
Good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Raihan Aziz. I'm from Mining Engineering Graduate Program at Institut Teknologi Bandung. And I'm honored to present our paper entitled Engineering Intervention for Pit Lake Overflow, Reusing Existing Water Monitoring Facilities as a Sustainable Post-Mining Water Management Strategy. This research was conducted as a part of ITB and PT Berau Coal Mine Closure Planning Collaboration. And I would like to thank to my supervisor, Pak Rudi Sayoga Gautama, and the other authors for their invaluable contribution. Okay, let me begin with the background.
At PT Broko BMO2 Block 8 in this figure 1, the production is scheduled to cease in 2025, and the final design will form 3 voids, like in the figure 2. There's a void CH and the northwest, and also the C1E. However, the current plan poses 2 critical challenges. The first one is overflow from the southwest pit lake will naturally spill into the northeast pit lake, disrupting the planned load distribution among water monitoring plants. And the second one is inundation of in-pit dam. In the figure 3, we can see that the water is at the 2 of the in-pit dam, raise geotechnical stability concern. So therefore, engineering intervention is urgently required to lower the overflow elevation and redirect the spillway correctly. And this is our research objective. Our goal is to create a good post-mining system, and we are focusing on the good water management system. To achieve that goal, we have 3 conceptual objectives. First, to minimize erosion potential from water flow, to support the revegetation and minimize the sedimentation. And the second one is to control the pit lake overflow. And the third one is to put the effort as minimum as can. And the design is we put the analysis from the upstream drainage and the downstream drainage and evaluate option for reusing existing facilities. We use 4 performance indicators. First is the flow number to measure flow velocity and the pit lake overflow discharge, to control the pit lake overflow quantity, and the material balance to measure the effort. And the fourth one is the distance from the spillway to the river to measure the risk. And this is our methodology, starting from the design objective. And then we do the data processing, and we begin with the rainfall analysis. We use the data from BMO2 station, starting from 2005 until 2021. Partial duration series was used from Gautama 2019. And we use the Gumbel distribution because it has passed the T-square and Smirnov-Kolmogorov statistic test. And we use the 2-year return period. First one is the 5-year, and the second one is 25-year event for the downstream. And we use the SCS method because it is concerning about the time lag and time concentration. And for the channel design, we use the Manning equation and trapezoidal for the ram and perimeter, and triangular for the bench. And this is the engineering intervention. Figure 2 showed that the original final pit design would allow overflow from the southeast pit lake to the northeast. And we engineered the overflow elevation down to the elevation 10 above mean sea level. And importantly, the water quality data from the Stiana 2022 show that the southwest pit lake received good quality water with pH 6 until 8 and TSS below the 400 milligram per liter. And this is for the upstream drainage. After we analyze the topography situation and also the catchment area, we finally found out the optimal dimension for the bench, for the ram, and for the perimeter drainage. And this is for the downstream option. For the option 1, the water will overflow to the catchment G, J, and L before to the river. And to create the channel, we need to cut the and create the channel, and we need to cut and fill for around 19,600 meter cubic, and the distance from the spillway is around 185 meters, and the peak outlet discharge is around 24 meter cubic per second, and the float number is already safe. And then this is the option 2. We are propose to reuse the existing water management facilities. There was a detention pond, sedimentation pond, and the channel. But because the capacity is limited, so we propose the retrofit the existing facilities. After we retrofit, like the table 6, we found that the performance indicator of engineering intervention is the material balance is 1200 meter cubic, and the distance to the river is around 100 meter, and the peak outlet discharge is around 24 meter cubic per second, and the float number is also below 1. So we've arrived to the conclusion. We are focusing on the table 8, I'm sorry. Option 2 requires the material balance less than 35%, and also the distance to the river is higher, or around 1,000 meters, and the peak outlet is similar, and there are no new land disturbance, so we recommend to use the option 2. And this is the acknowledgement and the reference that we use. That's all for me. Thank you for the attention. I pass back to the moderator. Thank you very much.
Thank you very much, Raihan. Is there any question from the audience here? Is there any question? I think this is a good research you got from the case study, right, in Braucol.
Yes.
Pardon me. It is also part of your thesis research or project?
Yes, this is my undergraduate thesis research.
Undergraduate,
Yes.
wow, I think it is. Okay, maybe I would like ask a question for you. 2 questions maybe. How did you determine that the existing, you use existing monitoring infrastructure, this already there before? Is this already used, or this is abandoned infrastructure?
Okay. Thank you, Pak Ari, for the question. The water monitoring point 32 is actually is still used at that time. We can see it from this figure that WMP 32 is in the southwest area. It maintain the water from the pit CD, and because the main development plan of pit CH will develop to the southwest area, so it is a prospect, and the final pit design is shown in the figure 3. So our strategy is to divide the water overflow to the 3 water monitoring point at the post-mining water management system. I think that's...
Okay, so what kind of intervention? This is just like we develop more for the existing infrastructure, or something like others intervention you mean in this research?
Okay, thank you, Pak Ari. The intervention is first one. I'm sorry. In the figure 3, this is the original final pit design from the company, and it showed that the water will overflow at 23 meter above mean sea level. In the southwest, it's shown in the 0.1, but the water itself, the water in the southwest itself will overflow to the northwest. So the water will connected between south east and northwest, and we engineer to leveling down the overflow level to the plus 21 meter above mean sea level to make the water not go to the northwest, and also it can make the in-pit dam will be more safe. Pari.
Okay, maybe the last question. What would you consider is the main limitation, or maybe we need their prerequisite if we want to use the existing infrastructure for your case study here?
Okay. The 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 priority aspect is the quality, the water quality, Pak Ari. Fortunately, the southwest area is good. The water quality is good, but actually we divided into the southwest go to the water monitoring point 32 because we want to focus to solve the water quality issue in the northwest. So water quality is very important to analyze in the first part.
Okay. Okay. Before we end this presentation, is there any question from the audience? No? Okay. I think that's all. Thank you very much, Raihan. I have something to give you, certificate. We move to the next presenter, Miss Alia Saskia Puspitasari. Yeah, we have 15 minutes in total.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. It's great honor to be here, and let me introduce myself. My name is Alia Saskia Puspitasari. I will present my research. Validation of remote sensing data with geoelectrical data to identify limestone in mining area in Central Sulawesi Province. I'm sorry, we cannot mention the area because something we cannot mention this area. Okay, next. Next. Okay. This study is integrated Landsat 9 remote sensing and geoelectrical to identify and validate the distribution of carbonate rock, particularly limestone, in Central Sulawesi. We use band ratio technique and mineral indicators are applied to detect spectral characteristics associated with carbonate mineral, while geoelectrical resistivity measurement provides subsurface lithological information for validation. Next. This is our study area in Sulawesi. And next. Then this is remote sensing method. We use band 4 and band 7. Why we use this band? Because the band 4 is red, This is sensitive to the vegetation area and non-vegetation area. And in band 7, we use this band because they're sensitive to vegetation, rock discrimination, and mineralogy variation associated with carbonate limestone. So the imaginary was obtained from USGS Explorer. You can download it free, and we just use band 7 and 4. Next. And I used the Werner configuration geoelectrical method 2 to get the geoelectrical data. Next. This is the result. The blue one is show that the high limestone, and the green one too. This is the right. This is the limestone too, and we grid the area with data geoelectrical, and the result is 70%. 70% data remote sensing validated with data geoelectric. Next. Okay. This is the data point that we have, the data. Yes, this is the data point and the logical, and this is the field lithology and 3D interpretation-nya, and its suitability with the field lithology and the data remote sensing. And next. Okay. The validation of 3D geoelectric model was performed by correlating subsurface resistivity distribution with field observation. Based into the inversion result, the model classifies for lithological zones is alluvium in the pink color. The resistivity between 5.55 to 13.9 ohmmeter. And sandy limestone, the resistivity between 13.9 to 208 ohmmeter. And the crystalline limestone is between 208 to 3,120 ohmmeter. And cavernous limestone is more than 3,120 ohmmeter. Okay, next. Next. Okay, this is the result from remote sensing data, and that's from the geoelectrical data. It's the remote sensing and the geoelectric data give the result for 70% similarity. I think that's enough. Thank you.
Okay, thank you very much. Finish the presentation?
Yes.
I see. Okay, okay. Okay, thank you, Miss Alia. Is there any question from the audience? Yes, please.
Okay, thank you. Good afternoon.
Afternoon.
My name is Asrim from ITB. Based on your geoelectric result, I see you have for lithology, right? So my question is, what kind of method to validate your for lithology? That's it.
Uh, Thank you. We have field data, but I separate my journal to the a few journal, uh, and this is the remote sensing validation with data geoelectrical, and we send the other journal to validate data geoelectrical with the field data. So we have a field data and geoelectrical data. So because my background from remote sensing, so I curious how effective remote sensing to interpret the data geology. I think like that. So, and I found remote sensing, we can use remote sensing for preliminary study, just for preliminary study, not for exploration, but just for help the geological engineering to find where is the primary limestone. Gitu.
Okay, I think in geoelectrical result based on the depth, right? Yeah, but enough for the outcrop for to validate for lithology for your result, because in geoelectrical is in depth domain, because in outcrop just just maybe 4 meter or 5, right?
Yes, I know that, but we know that the geoelectrical data more the grade of data is field data and then geoelectrical data and then the remote sensing data. So I try to validate the remote sensing data with the geoelectrical data, and then for the next journal we will we validate the data remote sensing and data geoelectrical to the field data. Like that.
Okay, thank you very much.
Okay, thank you very much. I have a small question.
Okay.
You use two kind of data sets from remote sensing data and from geophysical data.
Yeah.
And the primary of the result from remote sensing is to detect the surface condition. And for geoelectrical subsurface condition, this is very interesting. How you combine these two kind of data set to produce or to get the better result for mineral exploration.
I use the band 7 and band 4 in Landsat data because the 7 Landsat, the 7 band is sensitive for the lithology. and we have the geological data to the geological data, and that's why I try to validate the data remote sensing to the data geoelectrical. So if we can prove the remote sensing can be used to preliminary surveys, preliminary survey, so we can help the geological engineering to find the aim of what they want to find. So not for limestone too. I try to I try to nickel too, and then to gold. I tried the data remote sensing for survey, preliminary survey.
Okay. Okay, thank you very much, Miss Alia. I hope you success with your future manuscript. You said that you will submit it into some journals.
Okay. I
Okay,
will submit.
thank you very much. And we have the certificate. Move to next presenter, Mr. Alam Budiman Tamsi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Alamudiman Tamsi from the Faculty of Mining and Petroleum Engineering, ITB. Today, I want to show you how we can create map geological structure using satellites in a place where the jungle hides almost everything on the ground. This is our work on multi-source lineament extraction in Malengan Gold area, West Kalimantan, Indonesia. Let me start with the problem. Lineament is simply a strike or curved line that we can see on the surface of the air. It can be a fault, a fracture, a zero zone, or a contact between two rock units. But here is the difficult. Not every line is geology. Sometimes road, river, plantation, and even image noise also make lines, like lineament. Now, in orogenic gold deposit, the gold sits inside zero zone and fracture network. So a gold host rock is between structure like zero zone. So the structure is not a bonus. It is the first thing we need. And in tropical Kalimantan, file access is very limited. Remote sensing is often our only regional view. So our study has four objectives. The first, extract lineament automatically from the seven satellites product. Second, build a consensus, keep only the lines the several independent sensor agree on. The third, measure their length, direction, density, their relationship with the rock unit, and the four, deliver a reproducible map where every single line carries a confidence level. This is the study area, Malenggang in Senggau Regency, West Kalimantan. It's cover about 922 square kilometer, close to the border with Kalimantan. The gold here belong to an organic system. The host is metasediment. It is hosted metasediment host rock, and it is located along zero zone. The most important host is the slat on the Balai Subot group formation. In total, we have 9 geological units from river alluvium and volcanic lava to sandstone, slat, and granite, and also metasediment. And we have only a file measurement of the rock attitude or measurement. To cover the gap, we use 7 independent products, 2 lens mission, and Sentinel. For the optical side, Sentinel-1 radar in VV and VH, which can see through cloud. The result ranges from the 10 meters up to 90 meters. Every sensor look at the same surface, but each one sees it different. Here is the workflow in 4 steps. We prepare the data, we extract lineament automatically, we fuse them by consensus, and then we evaluate them geologically. One step deserves your attention, metric harmonization. So we covered every parameter into the real physical distance. For example, one source radius of 75 meters used for all sensors. In processing, the optical data were normalized and reduced using principal component analysis or PCI. From each dataset, we select the component that show texture and edge most clearly. For the radar, we applied a 7 by 7 Lie filter to remove speckle noise. From DEMNAS, we generate slope and hillside using 8 different illumination direction. The extraction itself is canny edge detection followed by elongation, filtering, line linking, and replicatable removal. Now, the core idea is in this study, we group the product into 4 independent families: Landsat, Sentinel, Aster, and Radar. 2 lineaments are treated as the same feature when they are within 150 meters of each other, and when their direction differ by no more than 20 degrees. The dam hillside is deliberate. We use that the independent geomorphological support. This is the confidence classification. For that, we define 3 classes. High confidence, at least 3 families agree, or 2 families plus the dam. Medium confident, at least 2 families or radar support by them. Everything else is low, and we remove it from the final map. We are hiding the weak lines. We simply do them pretend to be structure. Now look at what its source produced on its own. Landsat gave 613 lines. Sentinel-2 gave only 45. Same area, same parameter, same processing. And Aster Thermal produced the longest line of all, but almost one third of them touch the edge of the image. That is a warning sign, not a discovery. This is message of the slide. A high lines count does not mean better geology. It only means the sensor is more sensitive to texture. And here is the same result. See at as map. Look at the top row, Landsat 8, Landsat 9, and Sentinel-2. Then the radar in the bottom row. Notice how the radar concentrate its line in the west along the strong topography, while Landsat spread lines almost everywhere. Its sensor tell a different story. None of them is the whole truth, and that is exactly why we need a consensus. So here is the result of the fusion. We started with 152 candidates line. After the confidence filter, 255 survive, 31 high, and 224 medium. That means we discard 88% of our own data, and that is intentional. The remaining 250 kilometers are the lines we are actually willing to defend. And one of more check, are we simply redrawing the geological map? Of course, no. One average only 5% of alignment follow a lithological contact to median is 0. These are the ROS diagram. It's individual sensor on the top and the final consensus at the bottom. The individual sensor look nicely. They point many direction at one, but after fusion, one thread becomes clear: north, northeast to south, southwest, and north, south. The strongest been in 20 to 30 degree. And on the right, our egg file measurement of the rock strike, they fall in the same range. Egg point in small number, but the rock and the satellites are telling us the same thing. This is the density map. The average across the whole area is 0.27 kilometers per square kilometer. The break zone is in the west and the southwest, with additional cluster in the north central and the central east. But please be careful with a map like this. High density does not automatically mean more fall. Relief drainage, rock exposures, and how hard the rock is, all of this change how visible. For conclusion, one, harmonizing the parameters into the real distance makes several different sensors comparable. Two, line count is not structure quality. Three, the consensus is strict. And four, the highest density, almost 1 kilometer per square, is inside Balai Sebut slat, which is the no host rock. I think that's all. Thank you very much.
Yeah, thank you, Pak Alam, for your nice presentation. I will give to the floor. Is there any question from the audience? Yes, please, Pak.
Okay, thank you, Pak Ari. I see your Landsat is very good, but I have some question. why there are different between the Landsat result and the outcrop. That's it.
Okay, thank you. The result from the study different between data set from the structure original from the host rock and the file, because I think the structure data, the original from the file, is only one location, and this map result is regional. So I think that is different, regional and only local map.
Okay, so based on your result, what kind of Landsat that related to the outcrop result? What kind of method on your Landsat that related or maybe the same for the outcrop result for the line
Yeah.
of alignment? Thank you.
I think there is some result. If we see the result on the center of the map, I think there is some direction. If we look at the regional data, we maybe look at the different direction, because that is many data, many lineament. But if we look at the result for this study, we look at the same result direction. I think northeast. Yeah, same data. Yeah, I think like that.
Okay, thank you very much.
Okay, is there any more question? Pak Alam, I just have a small question. What kind of PC you use in each satellite imagery? There's a PC5, PC, where this PC come from?
Yeah, I get the data from Google engine, for get the data, and I think PCA is different. We reduce the pixel, and then after that the result, we use the data is from the shadow of the from pixel. So I think that is the Sentinel and Landsat, and what Aster different different with what Demnas, because the Demnas we use the topography, hillside, and Landsat we use the shadow of pixel.
I mean for simple component analysis. It's come from all bands from each satellite imagery you use. Then we get the PC5, PC something.
Yeah, only a lot of PC, PC5. Yeah, we use PC5. I don't show that in my presentation, but we use PC, the major PC, to use the data.
Okay, thank you very much. I think we have already enough. It's more than 15 minutes. Thank you very much, Pak Alams. I will give certificate. Okay, last presenter, Mr. Wahyudi. Am I correct? Yeah, correct. Wahyudi Zahar.
Test, okay. Of the arenum deposit and their relationship with the geometrical model. Yeah, one of the main challenge in mineral processing is ore variability. Variation in mineralogy, geochemistry, texture, and metal distribution may result in different metallurgical response. So therefore, a geometrical approach is needed to integrate geological characteristic with processing behavior. This integration can provide a better understanding of ore variability and support future predictive modeling. Yeah, based on the background, the broader research of our main stage, characterization, domaining definition, metallurgical, and metallurgical response evaluation, and predictive model development. In this presentation, I will mainly focus on the characterization and preliminary domains definition. So the overall objective is to develop a predictive geometrical model based on integrate geological, mineralogical, geochemical, and metallurgical data. However, the present study focus on the initial characterization and domaining stage. The slide shows the overall research workflow. The study starts with field characterization and systematic sampling, and followed by petrography, minerography, XRD, XRF, and geochemical analysis. These dataset are then integrated to define preliminary domains. In the next stage of the broader research, this domain will be evaluated through metallurgical testing and predictive modeling. Now I will start the field data. The study was conducted at the Arenum epithermal AUIG system prospect in Garut, West Java, Indonesia. The study area is located within the mining concession of PT Antam Tbk. In our investigation, focus on an underground exposure of the quartz vein and its surrounding altered wall rock. This exposure provide an opportunity to observe the lateral variability across the vein system. This is a total of 33 samples were taken systematically, collect using the channel sampling method across the wall rocks, quartz veins, and another wall rocks. IRN1 start from the right side, point A, and continues toward IRN33 in the left side, point B. This systematic transect allow us to evaluate the lateral change in texture, mineralogy, geochemistry, and metal contents across the vein system. Structurally, the main quartz vein is oriented approximately north 310 degrees east or northwest southeast. And this orientation is parallel to the dominant fracture system. A secondary northeast southwest fracture set cross cut the vein, and this structure feature indicate the important roles of fracturing in controlling hydrothermal fluid pathway. And this is the picture of megascopic observation. So the clear difference across the transect at the wall rock margin, such as IRN1 and IRN30. Alteration minerals are clearly visible, particularly clay minerals and locally chloride. Moving into the quartz vein, the different epithermal texture become visible. Sample IRN5 and IRN9 show fuggy and calm texture together with locally disseminated pyrit and brownish staining. And other vein sample shows additional textural variability. IRN12 show colorform texture, while IRN14 show crustiform, colorform, and fuggy texture. This observation indicate multiple texture with the quartz vein interval. And toward the vein margins, the rock become more heterogeneous we begin to observe quartz associated with clay minerals, chloride, sulfide, and stronger brownish staining. And this is the result from IRN1, microscopic and XRD observation, support the megascopic observation. In IRN1, the altered wall rock contains quartz together with sericite, carbonates, and other alteration minerals. And in contrast, at IRN14, represent the quartz-rich part of vein. The microscopic and XRD observation confirm the strong dominance of quartz in this interval. On the opposite wall rock side, IRN32, again shows a more complex mineral assembles compared with the quartz vein core. The indicates clear lateral mineralogical variability. And this is at the microscopic scale. The quartz vein also shows significant texture variability. We identified comb, mosaic, and saccharoidal texture in different samples. The observation demonstrates the even with the quartz rise interval, the vein is not texturally homogeneous. Moving towards the transitional zone, quartz become increasingly associated with the sericite, clay minerals, and opaque minerals. And iron 18 is an example of this quartz clay sulfide transition. And this is further toward the margin. Carbonates become increasingly important. This sample show mixture of quartz, sericite, carbonate, and locally fuggy texture. And in iron 32, carbonate is even more prominent, supporting the transition from the quartz-rich vein towards carbonate-bearing altered wall rock. And this is minerographic observation, also identify sulfide minerals. Pyrite is the dominant sulfide with locally associated with sphalerite. Minor chalcopyrite is also observed locally in association with pyrite and sphalerite. This confirms variability in sulfide mineralogy across the transect. And hematite also observed in several samples, indicating variable oxidation within the vein and surrounding altered rocks. And in IRN10, we also observe possible gold-bearing phase. However, this identification is still preliminary and requires further confirmation, for example, by SEM EDS analysis. When we look at the XRD result across all 33 samples, a clear lateral mineralogy pattern becomes visible. The central quartz vein interval is strongly dominated by quartz. In contrast, both wall rock margin contains high proportion of clay and carbonates minerals, and therefore the XRD result quantitatively support the field and microscopic observation. And a similar pattern is observed in XRF data. SiO2 increased significantly within the quartz vein core, while it decreased forward the altered wall rocks. In contrast, other major oxide associated with alteration become more prominent toward the margins. And this geochemical pattern is consistent with the mineralogical zonation observed from XRD and microscopic. The metal content and provide another important observation. AU and Ag enrichment is mainly concentrated within the quartz-rich interval. The highest value occur at iron 5 with 3.99 ppm gold and 30.3 ppm silver. In comparison, the surrounding altered wall rock generally so much lower AU and Ag content. Base metal and pathfinder elements also show local variation across the transect. And the key points of this study is that this dataset are not interpreted independently. Megascopic observation, petrography, minerography, XRD, XRF, and metal contents data are integrated. So this integrated approach provides the basis for defining the preliminary mineralogical geochemical domains. And based on the integration of this dataset for preliminary mineralogical geochemical domains were identified across the transect. The first domain represents altered wall rock, characterized mainly by quartz, carbonate, and clay mineral. The second domain represents the quartz vein, which is strongly quartz dominant and corresponding to main mineralization interval. The third is a transitional domain characterized by quartz with increasing clay and locally carbonate. And the fourth domains represent the altered wall rock on the opposite side of the vein. Importantly, these domains are defined from the integration of multiple datasets rather than from a single analytic method. So to conclude, I would like to highlight three main points. First, the Arenum vein system show clear lateral textural, mineralogical, and geochemical variable across the wall rock quartz vein, wall rock transect. Second, the quartz-rich core represent the main mineral zone with the strongest AU and Ag enrichment. And third, integration of geological, mineralogical, geochemical, and metal content data allow us to define four preliminary domains. This domain will provide the basis for future metallurgical testing and predictive geometrical modeling. Therefore, the observation geological variability may provide an important basis for understanding and predictive future metallurgical behavior. Thank you very much for your attention.
Yeah, thank you very much, Mr. Wahyudi. Okay, is there any question from the audience? Yes, Pak Asrim, please. Thank you very much.
Okay, thank you, Pak Ari. Pak Wahyudi, I think it's a good presentation, yeah. I see you have 33 sample, right? So my question is, what's the length of your sampling, and how about the interval sampling? Thank you.
Sorry, I can hear clearly.
The length of sampling.
Okay.
And interval sampling.
Sorry, what's
Line of sampling?
Yeah.
And interval of sampling.
Sorry, Pak Ari?
Line.
Line sampling and
interval.
Oh, okay. Yeah. Okay, can I present? Okay. Okay. The 33 samples was taken for one line. The total length of the line is 8 meters, but the all of the sample is not every 50 centimeters or 1 meters, but we choose from the different megascopical texture. So at the tunnel, the first time I saw all the all the objects to choose where's the sample should I take. So from the 8 meters transect line, we not separate every some meters or centimeters, but we choose the sample.
Okay, so what kind of reference that used to take each interval? What kind of reference?
Okay, the difference first we choose where's the batas from the wall rock into the vein. So at the wall rock we separate to where's the oxide and no oxidating at the wall rock. So we choose that difference. And at the vein system we choose from small texture at the megascopical texture. So every different texture we take one sample.
Okay, thank you very much.
Okay, thank you very much. Is there any more question? We still have maybe 1 minute. Okay, maybe I will ask a small question. This is your preliminary result, right?
Yes.
What additional data you need to continue this research?
Okay. What will I do to continue? So first I should check is this gold or no, because my study is about gold deposit. So first time I should find the real gold in my samples. That's I use the same EDS, and then I should next to the third data, the metallurgical response evaluation, and after make four domain, the last four domains is correct. So I will test the metallurgical response evaluation to take all the domains, how to get the recovery from the domains.
Okay. Okay, thank you very much, Mr. Wahyudi. There's a certificate for you to give. Okay, that's wrap for today's ICGERE. Maybe we will have a closing, and I will continue to MC, please. Thank you very much for your kind attention.
Okay, thank you very much for all of the speakers and the moderators for such an insightful presentation. And to distinguished guests, speakers, moderators, presenters, delegates, ladies and gentlemen, we have now reached the conclusion of ICGRI of 2026. Over these 2 days, we have shared knowledge and perspective across geoscience, mining metallurgy, geothermal energy, reservoir engineering, energy transition, and sustainable resource development. We hope that this conversation will continue through new research, partnership, and practical collaborations. On behalf of the Faculty of Mining and Petroleum Engineering, Institut Teknologi Bandung, and the ICGRI of 2026 Organizing Committee, we extend our sincere gratitude to keynote and plenary speakers, moderators, presenters, roster contributors, participants, partners, sponsor, volunteer, and committee member who made this conference possible. Thank you for your presence and valuable contributions. This officially concludes the 8th International Conference on Geoscience and Earth Resources Engineering, ICGRI 2026. We wish you a safe journey home and look forward to welcoming you again at the next ICGRI, and good afternoon. Thank you.